Hello, and welcome along, everyone. Hope you're all having a good weekend, good Saturday. It has been a mixed one here in Glasgow. We had some, little patches of sunshine, completely and then completely washed out the next minute by some heavy downpours. But it's been, interesting. All right. Haven't been streaming in a while. I was away on holidays, and just too busy. Basically, life is too busy. So back to reality last week, and now back to a little stream tonight. And what I'm going to do tonight now is I've been working on a little program, kind of sort of separately, and it's not for the Blitz Basic tool jam or anything like that. It's been for basically there's someone has ported the game Dark Forces to the Amiga. So now, if you know Dark Forces, they're like a Star Wars first-person shooter from the late 90s, and it runs quite well on a. Now, you need a beefy Amiga, but it runs quite well. So if you've got an 060 Amiga, with or without a graphics card, it's perfectly playable. And I know there's far more people than ever had 060s before, so it's quite the market out there for it. So that port is out, but the problem with it is that it had no way. The key mappings are stored in a binary file, so there's no real way of editing them without using a hex editor or anything like that. So what I did was I said I will I'll give that a go. I'll make a little GUI for that, because that's like exactly what we're kind of doing with the Blitz Basic in these tutorials, is kind of making small useful programs and showing that it can be done in Blitz Basic as well as making games. So I said I'll do that, no problem, and kind of thought about doing a stream on it, and then it just like too tired, too still in holiday mode, that kind of thing. So anyway, I have kind of got the bones of it together, and it is pretty much done. But I have some tidying and I got some feedback from the guy who does the port there today. So I said, you know what, let's do a stream on it, so I can bring you through the code that's in there. It is going to be open sourced when I'm finished it anyway, so you can all download it and have a go of it. But it's not complicated, but it has some features that I haven't quite covered, like reading and writing binary files, and a few other little things like that. So here we go. Let's have a look anyway. Here we are. This is our Blitz Basic, and we've called it TFE config because it's actually called the Force Editor. It's an open source engine for the game, so it's not the original game that's been ported. Actually, it's the open source engine that's been ported, but that works with the original game data files, and it all plays very, very well. I'll show you it now in a little while. Well, okay, I say that now. This is on emulation, so of course it runs very well. But here's my editor, and I'm going to take you through some of the stuff, because it's probably stuff that I haven't really covered. Now, there is some stuff in this that is Amiga Blitz specific. Okay, so you just have to bear that in mind and bear with me. Apologies for that, but okay. Hopefully it makes sense as I go through it. Welcome in, Graham. Welcome along, and cheers. Happy Saturday. Happy weekend. I am enjoying a nice little glass of red, just relaxing. Good weekend. Hope you're well. Have you been having a good one so far? Oh, good stuff. So you've got some me time now. When I say me, for yourself, you don't have to test my software. But so I'm actually, Graham has been testing this for me, and and giving some good feedback. But there's been some heavy downpours here as well today, so it's been a bit of a mixed one. Glorious sunset now, and then hefty clouds in the other direction. Sure, Scottish weather. But so Graham has been testing this software. I got feedback from I don't even know how to pronounce it. Basili on EAB, who did the main port of Dark Forces, or the Force engine. So I got some feedback from him, and I'm going to go and fix those couple of things that he was talking about, and hopefully polish this and get it close to a final version. So we start off with now it does use, like I said, a few Amiga Blitz features. So I'll talk about them on the as I'm going through them. But the first thing to note is that it uses a load of constants, which I've talked about a few times before. Always good, instead of having magic numbers here and there, is to give things constants. And I have a whole file full of lots and lots of constants in here. So so these are lots and lots and lots of different things that are defined in the game. So there are a few different layers of this, basically, or in the program. There are a couple of different layers to this. The first is the config file itself. So what I'll do is we can have a look at the config file here. Dark Forces, and I've switched to a small resolution, so it's the dock bar is quite big. Okay, and so the remapping file is this file. It's binary file, so it's not easy. It's not like a lot of config files or text files that you can edit. This is a hex file, which is mildly annoying. But this is the layout of it. That's what it looks like. It has some special stuff in it, but most of that, the bulk of that, is just key mappings. So in the game, you have basically the primary thing for inputs is an action, or I'm calling them actions. I don't really know what they're called, but basically, these are things like move forward, fire primary weapon, next weapon, use, pause, console. All the sort of single action functions that a game will have. They're all here, and each one is given a number internally, and they start at 0 and they go all the way up to 55, which is 37 in hex, I think. So that's them, and so each one of them has an entry, and starting here. So ignore the first line for now. Don't mind that. But each one has an entry, so you can see mapping 0. The next one is the type of mapping, and that's like, is it a keyboard, is it a controller, is it mouse? These kind of things. What kind of input is it? And then we've got what it actually maps to, and then you've got the qualifier. So the qualifier is like Control Alt Shift. One of these. Which of these keys is used for that function. So most of them you can see are 0. These numbers for the keyboard are key map numbers, but because it's not a native Amiga game, they're not native Amiga key map numbers, which is so we've got a layer of translation to do there. So each of these isn't if you're familiar with it, the game is done using SDL, which is what's it? Is it something like software direct media layer or something like that? It's basically an abstraction layer that lets software read and write to graphics and sound and controllers at a certain level, which is platform independent. So so it makes it easy to port games, because once you have SDL there, all the functions that the software expects are already there, and it can just use them. Now, it means it's not optimized for any particular, it's definitely not optimized for the Amiga. So once you have a game like that, you probably have to do quite a bit of optimization to get it to run nicely, but it depends on the game. But anyway, SDL it's primarily CPU driven. There's not a lot of hardware acceleration, because it doesn't use the Amiga sprites, or it doesn't make a lot of use of the various blitter tricks and things that the Amiga can do. So it's basically down to the CPU. But when you have a decent CPU, it opens up an awful lot of ports that otherwise just wouldn't be available, full stop. So, but yeah, it has its own input setup, input scheme, like all its own keyboard mappings, all its own stuff, and that's what I have defined in here. So, So like I was saying, we can see there the different action types. These can be keyboard, mouse, controller. Axis is an analog controller input. Oh, cool. Good to know. Good to know. This is 0.4 here. We can see that I'm working on version 0.4. I'm going to up that to 0.5 now because I'm going to release a new version maybe tonight or tomorrow with, or not release, but send out for testing with the various fixes that have been suggested. So, but yeah, good feedback because Graham was testing it under AmiKit, which has quite thick window borders, and because it's GadTools, I have to take extra care to make sure fat window borders, which are not normal on the Amiga, but are entirely possible, especially on the heavily modified ones like AmiKit or on OS4, MorphOS and things like that. It takes you have to take extra care of them. But yeah, so for anything, be it games or programs, by the way, this is a simple way of putting a proper Amiga version string into it. So the version string has a very specific format, but it's $ and capital V or colon space, and then you can put the name of your program and the version has to be just 2 digits with a dot. So it's 0.1, 0.2, or 1.0, 1.3, 2.5, but it can only be a number dot number. Has to be that format. And then in brackets you put a date, and again has to be this format. 2 digits for the day, dot 2 digits for the month, dot 4 digits for the year. When you do that, and you get the version info, and you can have a message after that. Sometimes you put like copyright information or a description of the program. So, and that's it. But once you do that, the Amiga OS version commands will change the date format to match your existing, to match whatever your local settings are, and it will also interpret the version number. So if you're using an installer or something like that, it will know which one's the one to replace and so on. So just to show you what that looks like, so on OS 3.9, 3.2 and stuff like that, if you go to get the info window open, and you can get the version, and you can see there it says 0.4 and the date. It doesn't give you the message because it doesn't give you that feedback on here, but that's it. And the version command will do the same thing. I'll show you that as well, sure. So, actually, no, we don't want to do it with that, do we? We want to do the shell, because it has drag and drop, the VNC, or, VNC. And we see, and we get the version number the same, that's just the version stuff, and you can do full, and it gives you the message and everything. So it gives you the date in, and see the way it's changed the dots to slashes? That's because of my locale settings. So it does all that interpretation itself, which is nice, but you have to get the format right in the first place. So that's how you do it. All you do is store that in a string then, and then it's part of the program. That's it. I've added this just as a small little thing, just to give basically for the about requester, just to give a 0.5 thing, just so that when you run the program and it has an internal version number on it, so that it can display that, so it doesn't display the whole string up at the top. But that's it. So that's a way to do that, and you can use that in games or programs as they are, as you make them. So back to what we were doing. We've got these various functions, and so each one has an ID number, an internal to the game, and a keyboard number. Now this is the default mapping file that you get when you run the game the first time. But what I'll show you is I've got the defines here that were given to me, and the actions are here. Now this is kind of a little bit of a slow process, but this is kind of one of the ways of doing it in Blitz, because I got it in a C format, and it was in a format of a string array, which doesn't quite translate to Blitz without a little bit of faffing about. So I did the faffing manually and organized it into the data statement. Now, if you're familiar with the various basics, you know what the data statement does. But basically, it just takes pieces of information. In this case, it's strings, and each one is separate and has in quotes. So it just takes constant information, and it lets you read it into the program on the fly. Now you can do it other ways. You can sort of stick them all together in a file and ink bin that file to include the file data in memory. But this is a simple way of doing it within the code itself. And that way, basically, that matches up with this read command here. So you can see that what we do is we just go through. We've got at the top of the code we define max actions, and that is here 55. So that's what I'm saying. 0 to 55 are the internal action numbers, and this is just a loop that runs through the action names and reads them into an array. So then we've got an array called action names with a string array, and they're not indexed 0 to 55, and each one of them corresponds with one of the names. So you can see here all the different functions that you have. You've got console, system menu, menu toggle, PDA toggle, night vision goggles, cleats toggle, gas mask toggle, headlamp. So you've got all these different functions. You can see turn right, look up, look down, turn left. You can see weapons 1 to 10, strafe left, strafe right, backward, forward, map layer up, map layer down. So you can see all those functions there. These are the kind of the user-facing descriptions of each of the functions, if you like. But there are 55 of them there, all in their own little quotes, and they're read into an array. So the internal function numbers now have something to describe each one of them. Okay, the next thing is these are the key definitions in SDL. So the SDL library, now I've added this one, so we'll ignore the unknown one for the moment, but the SDL library starts awkwardly in alphabetical order. Now this of course makes sense to everyone except the Amiga, but it starts there, and you can see these are the internal values that SDL uses for each of these keys. Now there are more keys defined here than there are on the Amiga keyboard. For example, F11 and F12, they do have definitions, and I've just copied them in and left them there, even though, well, the Amiga, well, classic Amiga isn't really going to read them by default. And then yeah, print screen, scroll lock, and stuff like that. They're kind of qualified keys in the Amiga, and they're not. Yeah, they don't really exist as such. And then you've got keypad and numlock buttons all down here, and they're all defined there. They go up beyond, so you've got like F13 to F24 kind of things as well here. These are all extra buttons that not every keyboard and most keyboards won't have, but they're defined in SDL anyway, because it's like every possible combination from every possible keyboard is there, every possible key input. So there you go. So there are lots and lots and lots of them there. And yeah, so there, you ignore key count actually, I don't think that's even needed. But we can see there are 286 of them. And they're the key definitions in SDL. So we have to convert them to the key codes on the Amiga. Now the key codes on the Amiga are not in alphabetical order or numerical order as such. They're in order of where they appear on the keyboard. So key code 0 is the top left button, which is the apostrophe on the Amiga. And then the key 1 is 1, key 2 is 2. So that, as far as 9, they match up. But then you go along and they don't really make sense. But let's see. There might be a key map in here. No. The actual printed Blitz manual has... Oh, this is printable characters. No, it's not. So the printed Blitz manual has the key map codes, but you can get them in the Amiga devs, the hardware reference manual. So, but yeah, basically they are in a certain order, and that order is defined down. Where have we got it? Here. So this is a translation array from the SDL to the Amiga key codes. So this is just showing you another way of filling up an array with data. So I've done it this way because the data commands only deal with like actual literal data that goes in your source code. What I've done is I've used the constants that we've defined and you can't use the data command for them or the read command, so I have to put them directly into the array. Now, it's using a little trick that I don't think I've covered before. Maybe I have, I can't remember. But the raw keys array, it's a word array, so each one is a number. So we're starting at 0, and the key grav is the PC keyboard equivalent. So it's the same button for opening the console on a lot of games on the PC. So it's the top left button, and you press it, and so we've assigned that to key 0, and then Amiga code 1 is assigned key 1, Amiga code 2 assigned key 2, and so on. But you can see here the little trick that I'm doing is, instead of saying raw keys index 0 is key grav and index 1 is key 1, you just separate them with a comma, and it will file each of those into an array, one after another after another. So it lines up the elements just as they are typed there, just separated by commas. And so long as you match up the information you're giving it with the data size of the array, that will work. So you're like, what we're doing is we're giving numbers that we're saying they're 16-bit numbers, and they're words, 16-bit words, and they're just assigned that way, and it reads them in. So I was counting them there. So the first one is so it files them one after another. So it does that until you run out of space at the end of the thing. So you can have a maximum of 250 characters. Now in Blitz 2, that's 128 characters. So the first thing that's going to happen when you load this into Blitz 2 is half those assignments are going to go missing, and you're going to get all sorts of errors, and it's going to be a dreadful mess. So so there you go. So this is Amiga Blitz only. That's one of the other reasons for using this editor, because it's pretty cool like that. So I've done that, and then I just counted there. You've got 25 entries or 26 entries there. So the next one is index 26, which is the 27th entry, left bracket. And so these are the Amiga key codes all the way along. Because I was working off key map, then I did it in hex because I knew which key was last and which the next key index is. So it's done that way. Now there are some unknown keys. There are some keys that are skipped in the Amiga key map. So you can see here key unknown, key unknown, key unknown. So they are presumably left as a little hole in the key map for the for extra buttons like page up and page down, because they do happen to match up with that. And like this, like there's a key unknown there beside right shift, which I'm going to assume is right control, because the Amiga only has one control button, and so it's unknown to the Amiga keyboard. But there's probably quite forward thinking of them, I suppose, when they defined the key map, but they left a hole in it there. And so there's a few of them that I need to take into account, but by and large all the keys are kind of mapped there. So now we have an array, and if we put in the Amiga raw code as an index, it gives us the STL value of it. Cool. So that's a nice little, it's a lookup table basically. That's all it is. But yes, I was up at the top, I was talking about the different action types. So the keyboard, and these are really input types. It kind of, when I was fumbling my way around, I named it action types, and I've left it like that. So keyboard is type 0, mouse is type 1, controller is type 2, axis is type 3, but an axis is an analog input on the controller. And they can be the analog sticks or the shoulder buttons. And the shoulder buttons are defined as analogs even when they're digital on the PlayStation controller. And this game has been adapted to use the PSX adapter for the Amiga, which can read all the PlayStation buttons, including the analog inputs. So it uses it as it would be on a PC or like an Xbox controller. But how the axes work, or how the shoulder buttons work, is they're treated as an analog input. So even if they're just a clicky button, they show up as a 0 when it's off and 255 when it's on. So like they go from 0 to full with a click a button. So if it's an analog button, it goes that. And so how the game treats this is, or how the game engine treats this is, if it has an analog axis and you define it digitally, it waits till it's halfway pressed or halfway through the axis, and then it fires that function. But we don't need to worry about that, but we just need to realize that there are some inputs that we might want to define as digital inputs that are defined on the axes, and indeed, and by default they are, some of them are. And then the last type is the mouse wheel, which is type 4. Now I've added a -1 because of how I treat them internally. Because the keyboard is 0, I didn't want to default to 0, so because I added a none function, which is actually -1. But so I have a way of defining that isn't, and that doesn't interfere with any of the other values. Then the qualifiers, these are SDL, these are from the SDL as well. So none is 0, and then Alt, Control, and Shift are 1, 2, and 3. So if we look at this here, we can see that this input type is 4. So that's a mouse wheel. So I know from just playing with this that these are the weapon up and weapon down functions. And they are, they're just defined as mouse wheel. And the mouse wheel only has, so these are all keyboard codes. The mouse wheel has fewer codes, and I'll show you them in a second. But you can see there that instead of 0 for the keyboard, these are 2 and 3. And if we go in here, we can see that these functions are defined further down. Are they? Or maybe I didn't. Maybe I hard coded them. Oh, I think I just hard coded them into the actual code. So we'll ignore those ones for this example. Let's look for other ones. So we see down here we've got 0 and 1. Or sorry, we've got action type 1. Actions 34 and 35 now. So controller type 1 is a mouse, and that gives and that's mapping function 0 and function 2. So if we look at the mouse defines, which are down here, where were they? Were here. Mouse buttons 0 and 2 are the left button and the right button. So the middle button is code 1. A lot of Amiga stuff doesn't use the middle mouse button, but it does support it in hardware, and I'm presuming the game supports it. And so if you have a mouse adapter, it should support the middle button as well. So that can be added as a mapping, but by default, it's just the left and right mouse buttons, and they're like your primary and secondary fire. So you can see how this works. So and yeah, these are the qualifiers. So not much uses the qualifiers, but some of them do. Some of them you need to hold down Shift, I think it is. So the qualifiers are up the top. So Alt is qualifier 1. So you can see that here we've got two functions, A and B, that are both assigned to the same key. It's keyboard because it's 0. So they're A and B. So they're both assigned to key 41, which is escape. But one of them uses just escape, and one of them uses Alt escape. So and that's how this mapping file works. Now each of the functions by default has a mapping, and so everything is all the way down there to 55, but they can all have a second mapping, and how that's handled in the file is that just extra the functions, it wraps around, it starts again at 0, and you can see here that extra functions that we have the same functions mapped again, but this time, so 1, 2, 4, 6, 7, all these actions are in there, but this time they're mapped to controller type 2, which is the controller. There you go. So they're mapped to the controller types, and then each of these is just a controller button, a digital controller button. So 2, 8, 5, D, C, E, A, 9. They're all the controller functions in hex, and we have all them defined down here. So SDL, being a PC orientated bit of software, has everything defined as an Xbox controller. So they're defined as A, B, X, Y, back, guide, which is one of the buttons in the middle, start, left stick, left shoulder, right shoulder. Now they're clicky, and left shoulder buttons that aren't analog. So the analog ones are actually, I'll talk about them in a second, but the analog ones are left shoulder, right shoulder, left trigger, right trigger. So they're not L1, L2, or 1 or 2. And then the D-pad functions are there as well. So they're how they're mapped in SDL. But here we have the axes. Now these are the analogs. So we've got left X, Y, right XY, they're the two sticks. Left trigger and right trigger are 4 and 5. So we've got 6 axes altogether. You know, hence the name 6-axis controller. Although, I think PlayStation talk about that when they're talking about twisting as well and motion controls. So yes, let's scratch that. But yeah, 6 axes, 6 analog axes there anyway. So so you can see there the triggers are 4 and 5, and yeah, all the buttons are defined there. Okay, so now this AA count is 4, so that's not actually saying that there are 6 here. That's just as far as I remember, that's just because there are 4 independent controls. So you got the left stick, left trigger, right trigger, which is 4, from what I remember in the code anyway. But axis count is the actual separate inputs that you can have. Okay. Oh no, I'll go back on that. The AA count, it's analog axes, and I know that while the triggers are analog as well, the AA count is the actual joysticks, is 4, and they're the ones that have sensitivity settings and stuff in the engine. So that's sorry, that's why they're defined. They're the first 4, so 0 to 3, and they're left stick XY and right stick XY. Okay, so I touched on that. The key names here, I did the same thing with the key names to make them nice and English, human readable. It just basically, this is a copy of the keyboard, so you've got up arrow, left shift, all those are defined, and they are defined versus the Amiga key codes. So if you have an Amiga key code, you put it into this array and you'll get the text version of the name of that key. So we go along, you can see that 9, and then 0 is after 9, then minus equals backslash doesn't exist, and then numlock 0 bizarrely, and then starts in the next row of the keyboard, Q, W, E, or T, Y, U, I, O, P, and then over to numlock 1, 2, or numpad 1, 2, 3, and then ASDF. So it goes through it in a bit of a funny order, but that's to do with how the keyboard is built electrically. And you'll notice if you have a broken membrane that if it's a row of the membrane is broken, all of those keys in a particular line will stop working. So you'll notice a pattern to it. But yeah, that's where the key codes come from, the Amiga key codes. Now what I've done here is there's a restore command, and what that does is when you're reading data into an array or into the software with the read command, it reads the first string or number or whatever data it is into it, and then the next one, it sort of has an internal pointer that points to the next one and the next one and the next one, and these will be addresses within the executable in the final compiled exe. But these ones are, it just has its own internal pointer, and it moves on to the next and on to the next. Restore moves that pointer to the label name here. So key names is the label I've given it, and you can see it's just here. So it just means that if there are more strings defined up here, that like if I add another one on here, this will never get used, but when you start to read the next one, it'll be pointing at this particular data item, and everything will be out by 1 then in the future. So using the restore command to point at different sets of data is just a neat way of keeping that all lined up. So you restore the pointer to wherever you want it to be, and that label is key names here. I put a dot in front of it just so it's easy. You can click on it here and it jumps to it, and yeah, you can see there's all the keys named, all the Amiga keys named. Okay, and then the same with this, we have the controller buttons, and then yeah, it's nice, and that's kind of it's an old school basic thing. It's one of those things that kind of it makes basic what it is, but it works quite well for things like this, where it's not particularly efficient or anything like that, but it makes the code easy to read. And it's in C, you would define them all in a list as an array, which is a more efficient way of doing it, because it's only stored once, but it's not really a big deal, and it makes it easy. But okay, so here we have the controller names, which is the actual digital inputs, So A, and because this game has been modified to use a CD32 pad, I've added a /red, blue, green, yellow. So back, guide, start. They don't have back and guide don't have an equivalent. Start is the play button. Left stick, right stick, those clicky stick buttons don't have an equivalent. But left shoulder is rewind and right shoulder is fast forward. And then you've got D-pad up, down, left, right, and they're the same on the Xbox controller. Now, the first thing I had in the feedback today was, well, that's great, but there's no way of connecting the Xbox controller to the Amiga. So it's a PlayStation controller interface, so these should probably be named square, circle, cross, and triangle. So I'm going to do that. But I'll do that in a little while after I've finished going through the actual how the program's set up and how the data's organized. But then the last one is axis names, and then there's axis count. So left X, left Y, right X, right Y, left trigger, right trigger. So they're what I talked about there. Just gives them human readable names. And they're all there and all defined in software, so they can be easily changed. And to change, we just modify it and recompile it. It will be possible to do them in an actual text file, and then people could rename them by editing the text file and read the text file in when the program loads. But that won't actually change the mapping. That'll just change the representation in this little program. So what I'm going to do, I'm going to run the program now, and you can have a look at it and see what it looks like. Oh yeah, this is just the data file. That's not, yeah, this is the code. And this is what it looks like. I've got a load of debug output, don't mind that for now. But it's this window here, and you can see that we've got a list on the left, which is a list view. We touched on list views before. All the functions are there. And so we can click on console. That's the first one I sent. And you can see that the first bind is keyboard, and it is the apostrophe key, and it doesn't have an alternative, because especially if you're on a controller, you're not going to be doing much with the console. Not going to happen. But if we go down to something that we are going to use, like jump, which is going to be used everywhere. So is that right? Oh, I think I was faffing with this earlier, so the mapping is going to be a bit funny. So, but yeah, so you can see on the keyboard it's numpad enter, and on the controller it's connected to the X button or green, which I think on a CD32 pad is kind of like the top button. So that would be triangle on the PlayStation. Okay, so what would be nice if we had those symbols in an Amiga font, wouldn't it? Or in the Topaz font. You could define a font, but I'm trying to avoid that. Well, we can see here that we have we can change what type of bind each one is, so we can set it to none. We can set keyboard, mouse, controller axis, or scroll wheel. So they're all our function, and you can see none is at the top of the list there. So a lot of the functions will have none because they're only available on the keyboard, like console. But we can change that. When we click get, we can open a new window, and that has that will detect our key press, so we can press a key. And what it does is it uses the internal lookup tables that I've done to translate. First off, translate the Amiga code. Oh no, it doesn't. It doesn't translate at this point. It's I'll have to go through that when I go into the code. But basically, it takes the Amiga raw code and it converts it into a string that it puts in that gadget just to show you what you've pressed. Some of them don't work because they're qualifiers, and the Amiga reads them as a qualifier, as in it expects you to press another button with it. So you have to enter them using this. So that's fine. That's just a workaround because you can't really capture it on the Amiga in that particular way. So that's fine. But yeah, it'll update this little thing here, and then you can choose a qualifier to go with it. So that function will fire with Shift X. So there you go. So I'm going to cancel that just to keep the thing. Now, other feedback I got today was that the get window shouldn't open, and indeed it shouldn't. I thought I had fixed that, but I didn't. But a blank window because there's no type attached to it, and but yeah, that shouldn't even be available. So what I'll do is I'll disable the get button when the function is set to none, And then we've got two other sub windows. One is for the mouse, and that lets you set some special flags. So you've got invert x-axis, invert y-axis, and you can change the mouse mode. We've got just 3 modes. None disables the mouse. Turn is just does left and right, and then look does left, right, up, down on the mouse. Then you've got X sensitivity and Y sensitivity. That's just a multiplier in the software, and it goes from, I can't remember what values, but it goes like half to double or something like that. And basically that's it. And it's just a multiplier that's applied. And the pad has similar. It's got sensitivity for the X axes and X and Y axes, and it has a dead zone setting which is defaults to 0.1, and it just sort of stops it from, takes care of the slight drift that you get in the middle of an analog stick. You can turn on and off the controller. That's just a flag that's in the config file. So I said, sure, I'll add it. And then you can invert the axes, left and right, X, Y. So that's it. So it's simple enough. But oh yeah, so basically all those functions can be found in the software, or in the config file. That's it for that. So I'll show you what the code actually looks like for this. It's tasty wine. So we're up here. We have some, I know most of the defines are in the other one, but we've got some defines in the actual main head of the code here. This debug I'm using to turn on and off the debug output, and I'm using a constant for that rather than just a variable, because you can do it that way as well and use an if then. But if you use a constant, you can use the compiler to turn on and off the output, and therefore the code isn't even included in the executable. So when you turn off the debug, it doesn't even contain those statements or those calculations. Excuse me. So, so it's just for size efficiency and stuff like that. It doesn't really make a difference in a program like this, but it's a nice way of doing it. So if I have some debug output here, you see, so cn if, that's for the it's a compiler numerical if, and it's basically you can do greater than, less than, but it's just it using it as a true or false. So if the debug is 1 or a non-zero value, it will print this this output. Man calc, can't even remember what that is. Oh yeah, this is some FPU kind of stuff, or yeah, this is some floating point calculations that I have to do. I'll go through that in a minute. But yeah, man calc, yeah. I was losing my temper with it at this stage, and I was just like, I just threw names at it, and it stuck with it now. So yeah. Man is Mantissa for you floating point fans out there. Mantissa. Yeah, which is kind of the numbery bit of a number, and then the exponent is the power it's for. Oh, excellent. Oh, spam-tastic. Oh, excellent. Let me sort that out now. Oh, I can't even remember where that is. I don't get much spam. It normally gets filtered out. Let me think. I suppose I should probably turn on the auto mod. Let me see. Well, let's just ban him anyway. There we go. And right, yeah, so it's probably like makes no difference at this stage because it's just a throwaway account. But anyways, there you go. Right. Where is the button for it? I can't remember. Anyways, sure, we'll leave it. Yeah, exactly. It's kind of annoying. Sure. Yeah, there you go. Grant. There's the button. Right. Okay, where are we? Where were we? Yes. Yeah, so, but basically, yeah, so this is quite neat for turning on and off debug output. And yeah, and it's quite good for, you know, if you've got different versions of a program, you know, if you have to do different types of code for like for OS3 and OS4 or MorphOS, you know, that for that kind of thing, it's quite good to be able to quite, you know, to create different executables quite easily. Now, yeah, so let me see what I'll talk about the floating point stuff in a little while when we get onto that fun stuff. But here we have some defines that I just use internally, and they're just here because they're kind of not really big defines like there, which are defining the kind of like the actual game side stuff. But this is sort of like internal to this code stuff. And they're kind of like the GUI constants. Like these are the constants that define the gadgets, if that makes sense. I'm sure you've seen that plenty of times before. And yeah, and then just some maxima, if you like. So some maximum values there. Maximum Amiga keys. They're the actual Amiga key codes. Max keys is the number of actual defines in the. Oh no, is it? I think that's the maximum number of actions that you can have. And then, oh no, the maximum of actions is there. That's 50, 55, 56. Max keys, I think they're the number of SDL defines that can be mapped to the Amiga. Yeah, I think so anyway. But then basically, yeah, they're the three main kind of maxima. So now I've set it up to, I normally, when I start a GUI program, I use WB to screen 0, which assigns the Blitz object screen 0 to workbench. But here I've done find screen 0, and there's a reason for that, and that is because find screen 0 will basically take the frontmost public screen and it will open the window on that. Now the reason for that is because when the game is running, the game will open a public screen and to allow windows to open on it. And it's because it's a multitasking game. So ultimately, this program will be run from within the game, and will open on the game screen, let you change the key config, and save it, and close back out of it again, and it'll all be on the one screen. So find screen 0 basically means it will open on whatever the frontmost public screen is. And there you go. So. And now we've got a couple of different new types that we need. So the list entry is the type of the actual array that's used for the list view. So the list that's in the gadget that has, you know, that has all the names in it. So it's not any kind of lookup or anything. It's literally just the names that go in the list view, and they need to be in an array. So we've got the list items array just defined down here, and you can see it is a list, so it can be expanded, and it's what you would call a dynamically linked list in all languages, I suppose. So it's not a traditional array, so the size is given as 0, and that defines it as kind of infinite or dynamically sized. So that is another Amiga Blitz only function or feature. On Blitz, you can still have a list type array, but you have to ultimately define a maximum size for it. So for this, like, you could give it 100 or something like that, but it just takes up memory. But that's that. The next one is an action. Now, within this action type, so the actions are the game actions, like walk, jump, run, fire primary weapon, those kind of things. So we've got this type, and inside that we've got little arrays that are 2 elements in size. Populated just tells you whether that action is actually used. This is something I've added recently because I rearranged how the program actually works. But that tells it, so if it's none, that will be 0, and if it's anything other than none, it will be 1 in here, in the populated field. And because we've got a primary and secondary bind for every action, we have 2 elements to the array here, and they're numbered 0 and 1. Now, unlike the outside arrays, like like actions, which is just a traditional basic array, which it has an index number from 1 to max actions, or from 0 to max actions. When you define it inside a new type, the maximum there, when you define 2 fields, you've only got 2 fields, and they're numbered 0 and 1. So if you try to access field 2, what you'll actually get is the first element of the next line, and that's fine until you get to the last one, and then you access the first element of God knows what. Could be the OS, could be your hard drive driver, could be, don't do it. So just be very, very careful that you don't access anything outside the number you give it here minus 1. The debugger will catch it at 2. So if you ran it, and so if you ran it like that, and it would with the debugger will catch the illegal accesses. But per line, it normally, with a normal array, with the round curved brackets, it will go 0, 1, and 2. So when you define an array, a traditional basic array, you give it a number, and it'll be, let's say you give it 2, it'll be 0, 1, and 2. So it's actually 3. So this actions array actually holds max actions plus 1 elements, which is actually 56, for example. But I could do max actions minus 1, but I couldn't be arsed. It's a few bytes, and it just gives it a little buffer at the end. But you have to be careful with that, because inside a new type, it's a different type of array, and you have to be careful that it's more like a C array, which is, you define the number of elements, and it says, okay, you want 3 elements, you've got 3 elements, and that's it, and they start at 0. So just be careful. So each of these has a 0 and a 1, and they are for the first bind and the second bind. Yeah, each your OS, each your input handler, each part of your game, each another part of this code, or another bit of data, or just something that you get away with 90% of the time, and then one day it'll crash and you'll never be able to find it and wonder why. You can spend 6 months with it working fine, and then one day it just crashes, and that's like, that's the worst case scenario. That's it. So, but very important. A lot of the time you won't do any damage to the OS because you're not in the last element. You'll just access the next element, because these will all be directly lined up in memory, one after another. But if one of these happens to be a pointer to something, you start storing pointers in here, then you very rapidly, it's crash town. Like, it will crash and burn quite rapidly after that. So, but just something to be very careful of. Use the debugger when you're writing code, especially with you should do it all the time anyway, but if you're dealing with these kind of arrays, especially, the debugger will catch it, because it can be one of these silent killers. Okay, and then we've got a few variables that are defined here. We've got the text font is the only fancy one here. So we've got word and long. They're 16 and 32-bit integers. Text font is an OS define, and that contains a pointer to the name of the font and the size of the font and a couple of other things. That is in the it's in amigalibs.res, but I've got all.res loaded up here. And that's an OS structure, an OS struct, and I use that basically to get the size of the window bar, but I don't think I need it. I think I got a different way of doing it anyway afterwards, so I actually don't think that's necessary. I'll leave it there for now, because but that's it. But now we've got another new type here. I can't remember why that's after. Oh yeah, this include line here is our TFE defines. That's this file here. So once we reach that point, now we've got all these constants loaded into our program. And even though, like in C, you would kind of think of this as a header file, but you can actually run code in this. It's a little bit more flexible about that. There's no kind of separate type for it's just a Blitz Basic file. It just happens, you know, it's a neat way of arranging things, but it doesn't differentiate different types of includes. So that's loaded up here, and that means that all those defines are available, and so now we have the AA count define. I think that's why it's in that particular order. But basically, this is our input configuration, and this contains all the details. You know, other than the actual keybinds themselves, these are all the settings that are in the config file. So we've got bind count is the actual number of entries, which is you know, how many you've actually defined, and that can change. By default, it's 70 or something like that. But that can change if you add more defines. It will, you know, it can go up to, what's it, 56, so 112. That's where the 112 comes from. Yeah, the maximum, absolute maximum is 112, because that's one for each. So that's where bind capacity is the maximum number of binds you can have, and I presume that's 112, but that is saved in the file. I don't know why it's saved in the file. It might be that there are different versions of the game that had a lower number, and so, you know, for future proofing it or whatever. Axis. So we've got 4 different axis entries, which is AA count is 4. So that's just saying how many axes there are, and it gives us sort of like a defined code for them. Controller flags, that's a field, that's a 32-bit number that contains like binary flags for invert this axis, you know, the controller's enabled, you know, that's they're all stored in that. I can show you that actually in the file itself, and they're down at the bottom. So you've got see these funny looking ones here. Each of these, each field here that you see like this, that's a 32-bit number. That's a long word. So 1, 2, 3, 4 bytes. Okay, it's a lot of programs will just use a long word. In Amiga terms, it might be a bit inefficient to use 4 bytes when 1 will do, but it's, you know, this doesn't come from the Amiga world, and a 32-bit number is fine. So, but it does allow it to be nice and neatly arranged in a hex editor. So you can see each one of these lines is one defined bind. Makes it nice and neat. But when we get down to here, we've got a few different things. So see these ones, the 01, 02, 03, they're the flag entries. And then we get down to here, so 01, 02, 03, 0, and 01. They're various different settings in the define. Where is it? What happened there? Right, so there are various different flags in here. So the mouse flags, so you've got the controller flags, and you've got some sensitivity and dead zone settings, and mouse flags and mouse mode. And there you see they're both long variables there. So you can see controller sensitivity here, dead zone here. They're floating point numbers. So they're not like, you'd often think of them as like 0 to 100% or something like that, but they're actually numbers from, they're floating point numbers. So they can be fractional values. They can be from, and I think in the game they're like from 0 to 1 for the dead zone anyway, and the sensitivity is 1 is like your standard sensitivity. So 2 means that it's twice as sensitive, and 0.5 means it's half as sensitive. So, you know, so you can adjust the sensitivity quite a way. But in the code of the game, I think it does impose some slight limits on it, but they are defined as a floating point number, and it's important to know that is how they're stored. So it's a 32-bit float, and they're there. So you can see here, there's a load of reading on that, and they're not stored in anything that you can easily read looking at a hex editor. So you can't really edit these by hand. Not at all. Not a chance. Not a chance. Well, I say that you could sit down for half an hour with a pen and paper and a scientific calculator, and you can come up with a value for it if you want. But yeah, basically you've got 2 floating point numbers here. They're the controller sensitivity, and the controller dead zone values here. And then you've got 2 more flags, so that's mouse flags and mouse mode. And you can see mouse mode is 02, and this is what I was saying before. If we go down to the bottom here, we can see mouse mode is oh, it's not in there, it's hard coded again, isn't it? Excuse me, sorry. When we were in the program, we did see mouse mode can be none, turn, or look, so 0, 1, and 2. So you can see how that translates to the binary file. And yeah, so that's fine. And yeah, okay. And then we've got 2 floats here, which are the mouse sensitivity. And so you can see mouse mode and mouse sensitivity .f is how you define a float in Blitz Basic. Now, here's the fun bit. The Amiga uses Motorola format floating point numbers, and that's all fine and good and dandy, and it works well with the Motorola. It's as Motorola defined it, works with their processors. Their CPUs can understand it, their FPUs can understand it, their, you know, everything, all their FPU libraries and stuff like that, they all understand it. It all works. The Amiga OS is built with them, and when floats are done natively in the Amiga, that's how they're done. It's not the standard. So there's an IEEE standard that actually gives us that, you know, that actually defines it as an international standard, defines how to format floating point numbers, and it is very different, primarily based on Intel machines. So we need to translate between them, and so the game expects Intel format. It saves and loads Intel format floats, and yeah, that's a bit of a pain. Now, wonderfully, the Amiga OS gives us the floating point libraries, and that lets us well, that's just one of the issues. Yeah, it is arranged in a different order, but that's only the start of it. Oh, it's great. It is yeah, it's it's fundamentally a different design. Like basically, yeah. So you've got the mantissa and the exponent. So you've got the or exponent. So we can see here I've got 2 functions here that swap them around. So IEEE to fast floating point, which is the Motorola format. So it takes a value and returns a float from. It takes a number that's in IE format and returns a Motorola format one. Okay, so you can see. So I mask it off. So the mantissa is the rightmost 23 bits. And the exponent is the leftmost 8 bits in the IEEE format. And yeah, and so basically, and the sign is one of the bits, is the very, very last bit, the most significant bit in the number. So the sign is actually basically part of the exponent. Okay, so that's fine, but the Motorola version is totally different, and the mantissa is, oh, let me see, what way is it done here? Mantissa is rightmost 23 bits. So let me think, it's the other way around. So the mantissa is the leftmost 24 bits on the Motorola, and the exponent is the last 8 bits. So that's opposite way around. You can kind of say, fine, yeah, that's okay, that's big endian, little endian, or whatever. But the problem is the sign is part of the mantissa, but in Motorola format, it doesn't like it doesn't like the most significant bit to be 0 of the mantissa. So the mantissa is the number bit. So if you've got like 1.23, the mantissa is the digits 1, 2, 3, and the exponent is the number of powers of 2 you need to multiply up to 1.23, which is an awkward way of putting it because the Mantis will obviously change when you take those powers into account, but that's the short version. So what happens is, if you end up with a 0, with the most significant bit being 0 in Motorola, it shifts everything over so that the most significant bit is 1, and then will adjust the exponent to it to compensate for that. So it gives it the best precision it can of the Mantis at the expense of the precision of the exponent, or the range of the exponent. The Intel version, or the IEEE version, doesn't do that. So you get a slightly less precision and a slightly wider range. But it means you can't just like convert the byte order. You have to calculate it all out and then calculate it all back in again. That was a pain in the hoop. Now, Commodore when I say Commodore, I really mean the Amiga OS creators, foresaw this, and they gave us the wonderful maths libraries. So the maths libraries in Amiga OS, if you ever go exploring the disk, you'll see that there are funny named files in the libs folder called like mathstrans.library, mathsingbas.library, mathdubas.library. They've got weird names basically, but they all match up to certain functions, and they are there for well, first off, they give software. Hey Dan, how are you? Welcome along. Yeah, Math IEEE or 4E, whatever it is. I'm in the depths of talking about and unraveling floating point numbers, which is and how to translate them between the Amiga and which is what is basically the standard, which is the Intel standard. So it's a tough one, and I had to do it by hand in this program that I was writing. So yeah. Yeah. Mm-hmm. But yeah, so there are loads of cool functions in there, and the joy of using those functions on the Amiga OS is that you don't need to worry about the different formats. As such, you don't need to worry about whether your Amiga has an FPU or not. The function will just work, and if you use those libraries, that's great. It will go much faster if there's an FPU, but if there's not, it falls back to using the standard CPU, and that's great. No one uses them, or very few people use them, because it's a little bit faster if you bang the FPU directly. So that's how we have FPU and non-FPU executables, because you just take away a little layer of the API to get a little bit more speed out of your number crunching, and that's it, which is a shame. So what they do is they hard code in the FPU stuff via the compiler instead. But using the maths libraries is actually really, really cool. Unfortunately, and the maths libraries do have translation functions for translating to and from the IEEE format between IEEE and fast floating point. So you can translate between them quite easily using functions. Now, I went looking into this, and I kind of knew those functions were there, so I was like, this is a piece of piss. I'm just gonna throw this function at the I'm just going to throw the numbers into this function, and that'll be it. Be fine. Didn't work. I don't know exactly what the problem. No, I think I know what the problem is. Sorry. But their function's called single precision to IEEE, I think. No. I will have to look at this. Blitz libs. No, it's not. What I need is my where is it? My library browser. And let's go and have a look at the OS. But anyway, how are you, Dan? Hope you're well on this fine Saturday evening. Oh yeah, so here's all our mathstrans libraries. So we've got fast floating point. So you can see they're the standard single precision floating point. And and these are the IEEE version. So if you're working with IEEE numbers, you just use the IEEE equivalent. And then you've got math trans, which lets us translate. So okay, so here's, yeah, sorry, math trans, yeah. So single precision to IEE. So if you go SP to IEEE, that's the function. That should be it. If we open up the thing with this, accepts a Motorola fast floating point and returns the same number converted to I standard single precision. Should just work. You think, I thought this is going to be handy, no bother. But it didn't work because Blitz saw this returned result and said, oh, that's a floating point number. I need to translate this back into my internal floating point number system, and absolutely mangled it. And you get basically random numbers because it does a kind of a conversion on what's already been converted. So you end up with sort of a double converted thing. You don't end up with the original number, you just end up with nonsense. So, and it's not even in the right order or anything like that. It's just, so basically I had to write my own functions. Yeah, exactly. Blitz treats everything as a primitive, like, you know, or treats floats and strings and stuff as primitives. And it is trying to be helpful. It says, I see this as a floating point number. I'm going to store this as a Motorola floating point number because I know that's what you want. So there. So it took hours to figure out why that was happening, because I thought I must be using this wrong, but then I did the code in C and it worked perfectly. I'm like, fuck you. So yeah, basically, so this is the funny stuff with the Mantis in Motorola format, and trying to get the most precision out of it. But basically, you'll notice that I've got this function and returns a float from the IEEE to fast floating point. The function I have for converting fast floating point to IEEE returns a long word, which is an integer. So what I do is, I was losing my temper, something serious. So I basically just do the entire conversion using peek and poke and binary funkiness, and then just store it in a long word, and then Blitz doesn't touch it. Now, obviously, I also can't use the number, but it doesn't matter because it's in binary format, and Blitz doesn't try to be clever with it. And so it's that's the raw value. So that is only ever used when it's written back to the config file. And you write a long word, and on disk it looks like a floating point number, and it works. And I had a pint when I got that working. Yeah, but what a bastard. I should point out that I didn't come up with this code. This was kind of a last ditch effort to, and that's why I'm using the very, very nondescript variable names, because I was just like, okay, I'm going to just try this algorithm that I found in a scan of a book from 20 years ago, 30 years ago. And I tried it and it worked first go, and I was like, you'll do. So I haven't touched it since. I haven't renamed the variables. It's just a black box as far as I'm concerned. I understand, well, I did understand when I did it how it works. I'm not even going to attempt to explain it, but there's a lot of bit shifting and a lot of swapping around of things going on there. But anyways, yeah. End result is, yeah, ancient books on Google Books or on archive.org or wherever it was that I found it. George, welcome along. Welcome in. Hope you're well. How are you? Welcome in. I have been disassembling and reassembling floating point numbers because the program I'm writing, which is a key configuration editor for Dark Forces. There's an Amiga port of Dark Forces, and it stores key maps in a binary format. So I wrote a little program to deal with that. But of course, they're in Intel floating point format, and I had to do some funky conversions because Blitz mangles the floating point things, even though the I was just saying the Amiga OS has some great floating point libraries, does the conversions for you, and then Blitz just shits all over them. So it doesn't like it. So I had to do my own conversions to and from Intel format or standard format. But welcome along. Now, just while you're here, hold those thoughts because I have run out of wine. So I'm going to go and get some wine. Back in a second. Raw. Yes, talk among yourselves. I hope you can hear the mods. Actually, I have some mods playing. I know they're quite quiet in the background. I can hear them. Oh, that's a good sound. Now, so anyway, yes, glad you're doing well, George. Cheers. I always remember there was a poster in my primary school, and this, you know, to this day is like, you know, has stuck with me, so it clearly worked. But it was a poster of some kids standing on their heads, and it just had a sentence under it, like they're standing on their heads over there. And I was like, yeah, that's how I learned at about 6 which was which. And it's still there, still locked away. There you go. That's it does. It works. At least that bit of it. And then most of the rest I remember from primary school is Basic on the BBC Micro. And how I actually wrote a game when it was raining really heavily and we couldn't go out in the yard. And it was a very quick game where you got two characters that move around the screen and one chases the other. And it was just like WASD and the arrow keys, and one person was an asterisk, one person was a hash symbol, and you just chased each other around. And that was it. It was brilliant. And for a lunchtime I was a god. But anyways, there you go. It's kind of, I'm not even sure if I'm pretty sure I had my Atari at the time, but yeah, my first main programming experience was with the BBC Micro, even though I never had one. It's kind of on my list of I don't need any more retro computers. I don't want any more retro computers, but if an offer came along for a BBC Micro, I probably would take it. But I'm not going out looking for it because, you know, danger, Will Robinson. Okay, so yes, so that is yes, so that's what we've been doing. The Electron, yeah, the Electron is kind of like a cheap version of it. Yeah, Arik seems to be a big fan of of the Acorn machines, the 8-bit Acorns anyway, probably the bigger ones as well. But like the BBC, I know if you've seen Micromen or you know the stories of that stuff, the BBC was like, there was a no holds barred machine. Like they threw everything at it. It's absolute Rolls Royce of an 8-bit machine. Kind of has everything in it. Has maximum expansion on it. Ours had a 3.5-inch floppy drive. It's nuts. Like you can connect multiple machines together for parallel processing. It's like fucking hell, it's insane. You know, people, there are Raspberry Pi powered accelerators for it that are legitimately following the system specs. Like, it's designed to take that kind of stuff. It's bizarre. It's amazing. Hell of a machine. And phenomenally expensive, which is why they were kind of only ever used for schools and by the BBC. But, like, it had spreadsheet and word processing programs built into the bloody thing in ROM. It was nuts. But, yeah, the Electron and the Atom are kind of like cut down versions of that, I suppose. Yeah, the Electron's a cool little machine. And it has a lot in common with the BASIC that it uses and stuff like that, but it's obviously much more, much more limited. But yeah, so that was the start of my programming back in the day. It's a good BASIC as well. It's a good version of BASIC. Because it has quite a fast text mode on the screen. The colors are kind of your, what are they called? I was going to say CGA colors, like the Spectrum, but it doesn't have the. It can handle them a bit better than the Spectrum, but it's still limited to whatever it is, 7 colors plus a couple of shades of grey. Anyways, yeah, great machine. So, if anyone wants to donate one to me, I won't say no. But yeah, so that's the story of all the floating point shenanigans that had on here. Yeah, 50 quid. Yeah. Oh yeah, like Stephen Elliott, 50 quid. For a second there, I thought you were offering. Yeah. Yeah, exactly. Yeah. And for an extra £5, I can write a receipt that says 50 quid. But yeah, all the floating point shenanigans there. It's a bit. I haven't stress tested these routines either, so they work between the values of say 0.1 and 2. I don't know if they work beyond that. In theory, yeah, oh yeah, I remember that actually. But in theory, these functions will convert any number, from from the minus billions, or from hundreds of decimal places all the way up to billions and billions. But I haven't stress tested it beyond 0 to 2. But I know that much works, and that was all I needed for this, so I've left it at that. Someone else can stress test them once I put it on GitHub. Okay, so our action defines. So we can see here we've got an array, and it's a traditional type of indexed array with max action elements, which is 55, which is actually 56. And it is the variable type action, which we have defined up here. So each of those elements actually has a populated 0 and 1, an action code 0 and 1, action type 0 and 1, map code 0 and 1, map qualifier 0 and 1. And they're the values that it reads out of the config file, except for populated. Populated says whether it's in use or not, but all the others are out of the config file. So if we look here, we've got the config file is looking like, okay, so the first round is like 0, and we can see their function 01 is also down here. So it means there are 2 binds for that. You can get it with the keyboard, you can get it with the controller. A group of Italians, welcome along, Kareem. How are you? And cheers, happy Saturday. Here's my favorite non-nerd. Hope my wife didn't hear that. Favorite non-nerdy stream follower, let's put it that way. I'm all good. Getting better by the sip. Yeah, it's busy all week. First full week back after the holidays. It was a hefty one, but yeah, it's all good. I'm doing something here that you might actually appreciate. It's some of the old Star Wars game, Dark Forces, was ported to the Amiga, and I'll run it now in a minute and just to have a look at it. But it is an old game, Like you know, I know your definition of an old game is something pre 2020. My definition of an old game is last century. So so there's a slight gulf there, but that is a game from the late 90s or so, I think, and basically the Amiga port came out, and it's all great and it's lovely and dandy, but the config file, if you want to change the key mappings, you have to go into this binary file here and edit numbers, and it's pretty rough. So I wrote a little program that does it for you, and I'm going through that, and I'm going to modify it. I'm going to add some functions, and that is my that's what my stream is about, and how to do things like that in using Blitz Basic on the Amiga. So I actually did think about entering this for the Tool Jam. So I don't know, Zuperdan, if you're still there, let's give the jam a shout out, because we should do that. So this is a game jam for non-games, and it's a competition. We've got a few months. It ends in October, end of October, I think. And the idea is that we make tools, useful software that are not games for the Amiga. Now, this is quite a simple one, so I'm not even sure I would think of this as an entry. But you know, this is well, you know, maybe I will. I'm going to throw a load of stuff at this competition and see what sticks. But yeah, it's the software I wrote will go and modify. You can see this binary file here, and what I have done is the program I wrote looks something like this, and puts manners on it. So you can see now, you can pick a function, and you can see what the what keys are mapped, and you can change them. So you can change this. So a mouse wheel event can be left, right, or up, down. So it actually supports 2 wheels on the mouse. Some have a second wheel, or you can click the roller left and right. Yeah, and you can map a qualifier to it as well. I don't know if that actually makes sense, but it's there. And you can see that on the controller, there's left shoulder button, or rewind on the CD32 controller. That's for next weapon, and previous weapon is there. So you can see wheel up, wheel down. So they're kind of standard controls for modern games. Wheel up, wheel down for cycling weapons, and for controller, they're the shoulder buttons. And yeah, so that's kind of how it does it. It puts manners on it. You can go in here and you can invert your axes. You can change your dead zone, your sensitivity. So it gives you all these modern controls for what is quite an old game. And to save you going in here and manually editing these numbers and looking up charts of key maps and stuff like that. And like, no, that's nonsense. So this is it. And I'm kind of doing this just because it looked like it needed to be done. And, you know, I thought, this is something that would be nice to do for the community. So anyways, that's it. So what were we talking about there? Yeah, so these are basically all our defined settings and stuff like that there. So our actions are there, and each action contains the 2 maps and each of the functions of the 2 maps, or each of the parts of the 2 maps. And then input config is just a variable that holds all these settings, like the bind count, the axes defines, the flags, the controller flags, the sensitivity, dead zone, mouse flags, mouse mode, sensitivity of the mouse. And they're all stored in a variable called input config. Now, the next bit is use path input config. And what that does is that tells the compiler that anywhere that I use a stem variable or field, I can't remember how it's defined, a subfield in other languages, but every time I use this, like a subfield or a stem variable of like one of these fields, without defining the variable itself, it assumes that it is the input config type, or the input config variable. So I'll show you what that means now in a second. So when you look at a normal, let me go down here and see. Let's see. Okay, so you can see here, this line here, it's / mouse flags. So that's the very same thing as doing input config / mouse flags. Okay, and this is just that's so basically it just stops me having to type input config all the time whenever it sees a / thing, Yeah. See, yeah. No, it's one of these things that gets into my head, and then it's like an itch that I need to scratch, and that's it. I'm like, ooh, I can do that, and no one else seems to be bothered because it's probably considered boring boilerplate kind of programming. But yeah, I'll do it. Get my name in the credits for a port. Yep, this is what happens as well. It's like, hey Rob, come on, do my thing, do my thing. Which is how things like this happen. that was what happened when I got hassled over WhatsApp during lockdown. You know, it ended up being full software hardware solution to a problem no one had. Yeah, this is true actually. It was Andrew who was playing Dark Forces. Like, oh, is there a way to change this file? And there were a few other people asking, to be fair. Not asking me, but it was Andrew asking in the chat. Okay, so incidentally, this is a way of doing a bit comparison in Blitz Basic. So the percent symbol means I'm representing a number in binary. You don't have to do it that way, but because binary 1 is the same as decimal 1, the same as hex 1, but I'm using binary just so that I can know when I go back to it that it's actually in binary format. And here we can see rechecking the second bit. So what we're doing here is we're ANDing the mouse flags. So the mouse flags is a number, and the first bit represents one function and the second bit represents another function. I think that's invert x, invert y. Okay, but basically the first bit, if the first bit is set, it means that the x-axis is inverted. If the second bit is set, it means the y-axis is inverted. So the first bit is represents the number 1, the second bit represents the number 2. And you combine the two of them, you get represent the number 3. But yeah, so you can see there that I'm just doing an AND, which basically will mean that only that bit is looked at. And if that bit, if the flags have bit 1 set, then it's true, and if bit 1 isn't set, if bit 1 is 0, then it's 0. It's false. So that's, it's a simple way of doing it, reasonably intuitive once you kind of know what's going on there. And then this is checking the second bit in the same way. So it's an easy way of checking a particular bit. Yeah, sometimes on my head too. Yep. Whoop indeed. But yeah, so there's how you do a bit check. You can do you can actually do bit test, which is assembly, and you do that as in so bit test 1 or bit test 2 to check bit 2. Oh, sorry, that would be bit test 0 to check the first bit test 1 to check the second bit, which is actually bit 1. So you can do it that way as well, and it's kind of going to be similar. That's probably faster to do a bit test like that. Yeah, it's probably faster, but I'm not. No, I want to delete that. I'm not too pushed with speed for this, so we can do an AND thing. Is kind of that's basically it's basically masks off bits. So because when you do an AND like that, it does a bitwise AND, and so every bit is compared all the way along the number. And so when the number 1, all the bits are 0 except for the bit that's 1. So basically everything gets cancelled out on the number except for this bit. And if that bit is 1 on both sides, then it becomes 1 on the output, and then that's true because it's not 0. So that's what happens there. But let's go up to where I was. So yeah, so that's what the use paths command does. It just tells me that I don't have to type input config all the time. And you can change that, but that's a compiler directive. So that is, when you use that, it's in source code order. It's not in kind of functional order or runtime order. It's as the compiler finds it. So you have to be careful to make sure that that takes effect. I've put it there just outside the function. That takes effect. Like, this is the first line of code where that actually takes effect, is the first line of the next function, even though it's not in execution order. Yeah, so you do have to be careful with it and just remember that's there. But I've just used one for the whole program, so all the code uses this as a kind of as the definition. So that's it. Just saves typing, but you can do that for whatever stem variable you want, or for whatever for whatever new type variable you want in Blitz terms. Okay, so I talked about those two floating point conversion routines. They're basically black boxes at this point. Now, SDL to raw. This is a key code conversion routine. So we saw earlier that we've got SDL has its own internal key codes that start at kind of like low down for A, B, C, D, E keys. Start at like 4, 5, 6, 7, 8, and it's in alphabetical order. It's in fancy order. The Amiga keyboard doesn't work at all like that, so we have to convert them. So SDL to raw converts an SDL key code to an Amiga raw code. So it takes a code.w variable, contains the SDL code, and it converts it to raw. Now, because my lookup table goes the other way, you have to cycle through the entire lookup table to find the value that you want, and then you get your result. It's an inefficient way of doing it, and realistically, if you were at all worried about the speed of it, you would do two lookup tables. So you've got one going one way, one going the other way. But how I've done it now is just because how it was in my head. I just cycle through it. So I go from 0 to, I go through every key code until I find the one that matches the code, and then my result is equal to whatever iteration of the loop it is. And that's it. Now what I should do actually is I'll add a little line here. And what that does is that means that I will then be bumped up to, once we've got a result, I will be bumped up to the last number of the loop, and then it won't cycle through needlessly once it's found a result. But if it does cycle all the way through the results and it doesn't find a result, it still returns the variable result, but that result is set to 999. And that's so I can identify it at the other end. So when I call this function, if I get 999 back, that means there's no equivalent Amiga code for the SDL code. And that will happen quite a lot because a PC keyboard has a lot more buttons, especially a multimedia keyboard. It has, and you got an FN, and you can get a load more functions that are defined, 200 and something functions. And if you get 999 back, it's one of those that can't possibly be mapped to the Amiga keyboard. Okay. So it is a bit slow and inefficient to do it that way. I've sped it up slightly here, but realistically I don't care at this point, because it's a cycle through something 100 times. If you were to do that in a game loop, that would absolutely kill the game. It would add milliseconds onto your frames, like dozens of milliseconds onto your frames. So it's not a good thing to have in general. But you do another lookup table. You do this once at the start of the program and translate every code. But yeah, I don't need it, and it does it once whenever you translate a button. So it's not needed. So I've left it as it is. It's a little programming exercise. I have left a comment there saying this should be optimized, but it's fine. Next, we've got this function here, which you can see it's a function of a string type. .s is kind of the same thing as using a $sign after a variable name in BASIC, but this is how it has to be done for function variables, for function definitions. Sorry, you use a .s, and that's a .string. So this function is going to return a string, and this will, if you give it a code and a code type. So these are Amiga codes. It will give you well, not just Amiga codes. This is the code, the controller code from the Amiga. and the type that it is. That's keyboard, mouse, whatever, because there's overlap there. You will get a string back that is the definition of that code. Okay, sorry, I didn't realize that was there. So so you can have, the reason you have code type in there is because you can have multiples. So you can have a code 0, which is the top, which is the apostrophe key on the Amiga keyboard, and it's also probably the red button, let's say, on the controller. So the controller, and it's the left mouse button. So remember I was saying earlier with the way I didn't have the strings defined, they're hard coded. They aren't defined in my defines file. It's because they're hard coded here. But this, the first thing it does is we split out based on the code type. So if it's a keyboard, it's very simple because the result is a string type. You can see here, .s. You can do result string either, but I just did .s to be consistent with the function .s. So if nothing happens, it returns the unknown code. Okay, so if it can't find it, but if it's a key code and it's less than max keys, so there's definitely a definition for it, an Amiga definition for it, it returns the key name string representing that code. And we remember here that is just these definitions down here. So apostrophe 1 2 3 4. So it basically returns you one of these from this array, and it's very simple. If it's a mouse type, and just for clarity I'll put a little line in there. If it's a mouse type, you can see left mouse, middle mouse, right mouse button. There are other mouse buttons, but I don't think they're supported. I can add them at some point if it turns out that it's needed. And controller name string, so that's another array that just stores up the controller button names. So that's the same thing down here. So 0 is, oh no, the axes. So 0 is button A or red, button B or blue, button X, button Y, and so they're the buttons there. So that's controller button count, or that's the controller code. If it's an axis, it returns the axis name, which is like left X, left Y, left trigger, right trigger, that kind of thing. And then the wheel up, wheel down, wheel up. Now I haven't defined the other ones because again I don't think they're supported on the Amiga, so so we've left off the others. Yes. And that's it. So basically your result will end up being one of these defined strings, and if it doesn't, it just falls out of the bottom of the routine saying unknown, and so you get unknown in the GUI, which is fine. You can see here this is a wrapper for that function. So this function is the get key name, and it takes an Amiga key code and the code type. This is get key name SDL. So this is the SDL key code and the code type. So what it does is it says if it's a keyboard type, again the result is unknown if it comes back confused. So if the code type is keyboard, it does the SDL to raw translation. Otherwise it just passes it straight through, and then you get the key name for that the raw key code, the Amiga translated key code, and the code type. So it's just kind of a wrapper that deals with the special case of an SDL keyboard, but passes through. If it's a controller or if it's a mouse button, it doesn't need translation, so it just passes straight through. And now we've got the big function, which is get code. Now this function opens the window that actually grabs the code. Now here's the thing. I've changed this code around, and I thought I had fixed a bug where it opens. I'll show you now. If we run this code and we click on, let's say, see this one here, auto mount toggle. I don't even know what that function is in the game, but I presume it's walk up to a vehicle, like speeder or whatever. Okay, so you can see this function's set to none, the second bind, so there's no controller type associated with that, so that's blank. If you click get, it still opens the window, and the bit up here is missing where you choose what the actual input is. So if you look at the keyboard one, you can see that it'll give you, actually a better example is this one, where it defines, you can see right shoulder fast forward and the qualifier is none. Okay. But yeah, the key thing is there, it shows you that it actually gives you a controller input there. But when it's set to none, it shouldn't open the window. So I don't actually know why that is. That's a bug, because here we have the selected action, which is whatever is selected in our list on the left, and the current bind is either 0 or 1 if it's the primary or secondary bind. And this returns the code, be it the key code in SDL format or the controller code from 0 to 15 or whatever number of buttons it is. But if the action type is none, it should return a result. Result should be returned 999. It should just exit the function there before it even opens the window. So I don't know why that's happening. And what I'm going to do is action type equals none. I'm just going to make sure that's right. Of course it's not. It's -1. Well, no, actually, no, that is right. It is none, sorry. It's hash none. So no, that's right. I was thinking, yeah, because it's expecting 0, but I think I translate everything off by 1 when I deal with the cycle gadgets. I'll talk about that later. But I don't know why action type isn't translating over. But what I might do is, I know. And remember what I was saying earlier about when you mess up the indexes or the indices for an array that's within a new type, it's often a silent killer. It's a bug that just addresses a different field. I bet you that's it. It's checking the wrong bloody one, and there's always one action defined for the primary because it all, well, there doesn't have to be, but there always is. And let's give that a go. There we go. Tick. So that's fine. That's satisfying. So there you go. So when you do that action type, because what happens is in Blitz is normally like a basic, this when you give an array index, it's kind of like an address of the array, but it's taken one bit lower. It's literally an offset into the new type when you define this. So it needs to be 1 because you need to step it one long word past the previous entry. It's literally that. It's literally an offset within the new type, and that's all it was. That felt good. But yeah, you won't get. Actually, I wonder if the if the compiler would have caught that. No, see, the compiler doesn't catch that, or the debugger doesn't catch that. So you have to be really careful with that, because internally Blitz treats these as just pointers. So we're spared the hassle of it, but it's literally just an offset to the pointer to this array element, and Blitz will catch this. The debugger will catch an error when it's in a standard indexed array, but not with the square bracket arrays that are inside new types. That's just a byte offset. The compiler just translates that, multiplies it by the size of a .l, and says it's an offset from there. So there you go. Very, very careful with that. The debugger won't catch that. Okay, cool, excellent news. So that's what happens there. It just errors back with the, or it just kind of falls back with the result code of 999, which is kind of undefined, and it doesn't open the window. But if it doesn't, if it is actually an action that isn't none, we open a window here, and we open our new window here with our own internal, just to this function. We have our own separate event loop, our own separate window setup here, just for this, just in this function. It's like a separate little program, and it just makes it simpler to keep it all self-contained like that. But what happens here is we set up our window, our gadgets, and we base it on the action type now. So yeah, so we take our current action. Now I should point out that we've shared these variables here, up here, which are the screen width, screen height, the raw key lookup table, the controller names lookup, the access names, and the actions are that the currently mapped defines. So they're all shared. They're all taken from outside. So they're not global, but they're imported into this function. If you're familiar with importing from other languages, so they're yeah. So what we're doing is we're checking the current action, the action that we're actually talking about, and we'll define the GUI based on that. So our first thing is, if it's a keyboard, we have a key and special key cycle gadget. So the key is just a string gadget. It's actually a text gadget, and the difference between a text gadget and a string gadget is a text gadget is read-only, a string gadget is read-write. So you can't modify the contents of a text gadget, but you can with a string gadget. And then we've got a drop down, like, or a cycle gadget that says special key. That's for entering keys that can't be captured with a single key press using the OS. So then, and then if it's a mouse type, we just have if it's a mouse or controller, we just have a cycle gadget giving the different options. So the mouse is, again, hard coded: left mouse button, middle mouse button, right mouse button. Oh, there's the extra mouse button defines. So they are actually in there. And then this gives you the default setting is what it's actually mapped to. So it actually does support them. I just haven't included those defines, but that's fine. It just ultimately just comes down to a number, and that is what will be given to what will be saved in the config file. Okay, so the controller. So here you see that to create a cycle gadget with these entries, we've got left mouse button, we have a pipe symbol or a bar symbol, middle mouse button, and right mouse button, and that separates the different options in the cycle gadget. So we can see the different, so we've got 5 different options there, the X1, X2, left, middle, and right mouse buttons. For the controller, that's a dirty big long string. It's got, 15 buttons or something on it. It just ends up being a big messy thing. But it's easier because they're defined by the data statements that I was looking at in the defines file. We've got them in an array, so we just go to we go in a loop to the controller button count -1, because that's an absolute count, not a start at 0 count. What is it? Ordinal versus cardinal? Yeah, that's an ordinal number rather than a cardinal number. No, the other way around. Anyways, basically, controller button count is actually 16, but they're numbered 0 to 15. And then what we do is we just add the current controller number that we're looking at in the array to the option string, and then we give options as the option string as the actual options, instead of typing them out into the command itself. So the cycle gadget just takes this big long string and has each controller name, and if we're not on the last iteration of the loop, it adds on the pipe symbol. So you get the first entry, add on pipe symbol, second entry, add on pipe symbol, third, fourth, fifth entry, or the fourth entry, add on pipe symbol. It's the fifth entry that is not far enough away from the end of the loop, don't add on the pipe symbol. And then we get a big string and we put that into our GUI there. Again, we use the current code, the mapped code, as our setting, so that when the window opens, it's actually set to the right one. And we do the same with the axes. So this is for choosing an axis to map. We have 6 axes, and we do the very same thing. It's the very same thing as the controller, just with a different array for the names. And then the mouse wheel is hard-coded. So mouse wheel, left, right, up, down. That's it. And again, it uses the current code to set the setting when it opens. And then we end our select. So they're basically determined by the type of controller. Now, the qualifier is valid for all of them. Now, it's valid for all of them in terms of the config file. I actually don't know. I haven't looked deep enough into the code of the game to see whether qualifier is actually read when you roll the mouse button or the mouse wheel, for example. I don't know. But because it's technically possible in the config file, I've just left it valid for all the input types. It makes very little sense when you've got a controller, to be fair, because you've got your hands full. Shift X or Shift Y isn't going to do you any good. But I've left it there because, yeah, again, it's technically possible. And then we've got accept and cancel buttons on the bottom. Now, the dimensions of these gadgets, you can see they're calculated based on the size of the window. And you've got Graham to thank for that, because I had made them without that, and they kind of overspilled into each other and into the borders of the window when you use thick borders. So there you go. They're all calculated based on that. And that's it. And then it just draws a box to make it a bit neater. And then we've got our event loop, which is fairly standard. We run and we wait for something to be pressed. Excellent. Good stuff. We wait for the event, and then we check first off, because this wait event statement here pauses the program flow until our program gets an event. Now, it doesn't matter what a window gives it the event. It'll fire off an event anyway. So wait event doesn't differentiate. So we have to check that's coming from our window. Now, our window ID is 1. You can use a constant for that. I've been a bit lazy and I haven't done that. You can see the same for the GT list here. But yeah, so we have to make sure it's from our window, and then we act on it. Now, it is also possible to open a window and have a combined event loop that handles all the windows together, and then you can do a select event window and have a separate branch of code for the first window, for the second window, all that kind of stuff. You can do it that way. But here we're just handling in its own separate one, which means that nothing can be done to the parent window. It won't react. You can still click the gadgets, but they won't react until the child window is closed. But yeah, this just filters out to make sure that if you click the close gadget on the parent window, it doesn't trigger the close. It doesn't trigger the child window to close, and so on. And click the ID1 gadget. So it's important just to know that you're talking about the right window. So close window, it's the same kind of idea. We just say it's true. Now, raw key event means if it receives a key press, and if actions is, we only react to that if it's a keyboard action. It doesn't make sense to react to the if you press a key and if it's the controller. So it's a keyboard event. It's a keyboard type controller, and it's a key event, and we check our raw code is the event code. I'll get rid of that. So when we start our event loop, sorry, it's just there, we have event code, and the event code is an internal code that is it's based on the context. It changes. It's relevant to the current context. So if the event is a key press, it contains the key code. If the event is a cycle gadget, it contains the value that the cycle gadget was set to. Okay? So we're saying our raw code, so that's a raw Amiga key code. But how the Amiga keyboard works is we get two key press events. We get one when it's pressed down and one when it's lifted up. Okay, so key, and each one of them is a raw key event. How it differentiates them is the key up events, the most significant bit is set, and the key down events, the most significant bit is cleared. Now that gives the end result of being, if the key code is below 127, it is a key down event, and if it's above 127, it is a key up event, because that bit is the most significant bit in a byte, and it counts for 128. Okay, so that means that the Amiga can only ever support 127 keys for a start, but it's done that way for an interesting reason, because if keyboard communication is ever interrupted, the key up event is the one, and it's kind of it means you're less likely to get a key stuck, and if you disconnect the keyboard or something like that, you get a key. The key up event is kind of a more, the key up event registers, I can't remember exactly what the reason is, but it's basically, it makes a lot of sense to do it that way rather than key down is the bit is set. But yeah, it basically means that a key doesn't appear stuck as easily as if you do a key down, which is cool. Okay, so basically, yeah, you have to be careful of that, because you will get two events for a key press, and it can give you some awful funny bugs, because you might get a key code that you don't expect, because it's like, it's 158 instead of 36 or whatever it is. If you put that code, a key up code, into the raw keys array, you'll get a crash because it's beyond the end of the array. We don't have definitions for the key up events, and we don't want key up events in a game like this. You want key down to trigger the function. And so, yeah, so that's basically it. So what we do is we if our key is a key down event, we use our function that we talked about earlier to get the raw code translation into text of the key. So it's a keyboard event. It is, we give it the raw code, and we get a string that says space or escape or A or B or F2, and then we just use GTSetString to set the GadTools text box to name string. Now, setString works for string and text gadgets, and so does getString. But yeah, it's just important to realize that there's no different. How are you? So you can use it. So even though text and string gadgets are different things, internally they're both the same, and they have the same structure. So you use the same command for setting them and getting the contents. So you set it to whatever this sets it to whatever the key name is, and we also get the result is the raw keys lookup of the raw code. Okay, so that gives us our SDL code. Is that what the function actually produces? Because that's what the config file wants. And finally, when you press a key, we set the special key cycle gadget to 0, because the special key cycle gadget is used for entering keys that can't be entered with the key press. So as soon as you do one that can be entered with the key press, we just blank that gadget. You can see that in action here. So special key, if we want that to be triggered by the left shift, okay, that's it. But if we actually press a key like T, it blanks the special key cycle gadget, because it doesn't make any sense to keep it there. It could be confusing. Okay, so yeah, that's it. And we set that to 0 for that reason. Now, here's the next one, is if it's a gadget up event, that means someone has, when you're clicking a gadget, you do want to act on the gadget up event. When you're responding to a key press, you usually want to respond to the key down event. Okay, so but here we're checking our gadget hit. So if it's a special key, the raw code, yeah, don't worry about this, is the error code offset. So the or sorry, the event code isn't directly the raw key. It's offset by a certain value, and that's just how it is. You just have to know you have to add a number to it. That's pretty sure that. I'm pretty sure that's defined in the OS documentation. If you were coding in C, you know, it's in the developer documentation. It's just the way it works. And yeah, so then we skip a blank in the key map. Yeah, basically this is kind of translating the gap that I saw, but God, it's special. Yeah, no, so I'm talking out of my arse. Absolutely talking shite here. This is the special drop-down gadget. Sorry, there is a there is an offset that you use for what is it? There is an offset that you use for when you're reading a raw key map in Blitz mode, and it's different to when you're doing it with the OS, and it's in the hardware reference manual, not the OS includes. Sorry, that's very confusing there. What I'm doing here is the raw code. So if you look at the key map, the qualifiers start at 5F, or start at 60 in hex, and this is just a shortcut way of translating them instead of doing them one by one, because they're all in numerical order, or they're all in a certain order as I've put them in the defines, except that number 2 is missing because there's a hole in it there, and I was saying about that earlier. It's the right control hole in it. Okay, so we skip that one, and it's just a kind of a shortcut. It's an algorithmic way of generating the code. Yeah, basically, if you look at the values of the raw codes, where are they? Oh, they're up the top, aren't they? Oh no, where are they? Okay, raw keys are, so they start over here. So you've got left shift is $60, is hex 60, and then right shift is hex 61, or sorry, left shift is I think 61, 62, key unknown, and then left control, left alt, right alt, and left GUI and right GUI. Now that's how they're defined in SDL. That is actually means the GUI keys mean Windows keys on the PC, Amiga keys on the Amiga, Mac keys on the Mac. You know, that's what they are. What are they called? What's it they called in Linux? Is it super keys? I think so. But basically that's what they are. But yeah, so that's what that little calculation is doing. Sorry, that was a bit of a shortcut. I probably did it late at night. Okay, the mouse is literally just the event code, and so they're the cycle gadgets. This is one place where, you know, in C, if you leave out the break when in a switch statement, it just falls through and they can all get the same result. It would be nice to be able to do that there, but Blitz doesn't do it that way. And the qualifier gadget we don't actually do anything if the qualifier gadget is set, and the reason for that is that it doesn't affect the result. When we set the qualifier gadget, the result that the function gives back is still the main event. You know, so it's what the main gadget is set to. The qualifier gadget can't be returned in the return values, so that's read separately. So when we click the accept gadget, we store the current qualifier setting. So that's the attribute cycle GadTools cycle active of the qualifier gadget, and we store that value in the qualifier field of the current action. So it's just a kind of we're writing it back now, whereas the actual code from the keyboard or the controller or whatever is returned as a result at the bottom here, function return result. Okay, and that's it. And so all we do is free up the resources, so we detach the GT list, then we free it. You can't free it first. You have to detach it first. Then you free it, then you close the window. And we activate the previous window with activate 0. And flush events is kind of important here, because what that does is that clears the event string, or the event stream, so that any events that were left to process when we close the window, like just say you managed to double click the close button before it closed the window, for example, so that event isn't still in the queue, because if you fall back to the previous window and you get a close window event still in the queue, it will fall through and it will close the parent window as well. So flush events just clears the event queue, and you do that after you've closed the window, so that it can so that no more events can be added to the queue unless they come from window 0. So that's all that is. This is just an error message to say we can't open the window. It's kind of a neat thing. Well, it depends on how you do it, because if you're in your main loop, you filter by the window that the event comes from, then you're fine. But it's just something that I found that happens, especially if the Amiga is slightly sluggish and you've got a dodgy left mouse button. It can sometimes click the gadget twice and you end up closing everything, and you're like, oh fuck, I'm halfway through my, I've done 50 defines in this thing and I've lost them all now. Okay, a little bit more. Yay. Okay, and then we return our result, which is the actual code given by the keyboard or the mouse, or it returns 999 if it's undefined, if the code doesn't make sense or if it's cancelled. So that's it. So that's the get window, which is this guy here, and that's all. That's all defined in that function, and it's all very self-contained and lovely. Mouse options is kind of the same thing, but it gives you the mouse options. Good question. I didn't explicitly deactivate 0, but obviously you can only have one window active at a time, and what you can see up here is the first flag I've defined when you open the window is window flag activate, and when you set that flag when you open a window, it will automatically activate the new window that you open, and thus deactivate the other window. So window 0 does get deactivated straight away as soon as you open this window. If you don't set that flag, you open a new window and it's not active, and it's kind of grey. So it's kind of, for programs like this, it's unintuitive to do it that way. So you do want the new window to open. But if you were opening, say, a toolbar or a preview window or something like that, you wouldn't want it to activate and take focus away from your current window. So, it depends on your application, what you're doing. But it's normal for, if you're opening a child window of settings or something, to set it to activate. There is an activate command, so you can activate a window on demand if you want as well. Now, so mouse options does the same kind of thing, and you can see it. It's the same window flag activate. Now, when you open a window, by default, it responds to certain events, and you'll see that I'm just doing a add IDCMP event here, and I'm adding the slider IDCMP flag to it. And what that means is that the window responds to events from a slider. Now, you don't always want that, because sometimes you only want to read the slider at a certain point in time, but I've added it just for completeness, and just in case I want to, and it's not a big deal. I don't actually think I use it, to be honest, but I don't use it, but it's not a big deal either way. But what I'm doing is I'm subbing out the mouse move event, and what the mouse move event is, it's literally every time you move the event when the window is active. So you don't really want that, because it triggers your main loop quite a lot, and even if your main loop doesn't do much, it takes up a bit of CPU time. And again, this is only going to be running on powerful Amigas, because you're only going to be running this game on powerful Amigas, so it doesn't really make a difference, I suppose. But if you're running on a slow Amiga, it's a nice way of getting a few extra cycles per, or saving a few extra cycles, because you're not wasting them basically by cycling the main loop when you don't need to. So and so the same thing, we're activating the flag, the window when we open it. The other flags I'm using are give it a close gadget, depth gadget, drag bar. Drag bar is your title bar. If a window will look pretty funny if you don't add that flag and you add the close gadget, because it will still kind of be there, but it won't have the borders around it. It's mess. Yeah, exactly. So all the events have a purpose. Someone put them there for a reason, and it's just that it defaults to enabling that event. So even if your program isn't doing anything with the mouse event, it's the mouse buttons are a different event. Mouse click, it's a IDCMP mouse click, I think. Mouse click and mouse move, I think they're the two events. But yeah, it's just because it's set by default by Blitz for whatever reason. So sub IDCMP just pulls it out of that default list, and just means that you're not firing it up. The reason I did that actually isn't really to save CPU cycles. It's because when I was debugging it, and I was just outputting all my events, and so I'm moving the mouse around, and my console window's just full of events. And I'm like, oh, that's not what I wanted. So I can't see what I was actually looking for there. So so I disabled that event, and it makes sense to leave it disabled unless you do need it. But yeah, if you are looking for, let's say, to read the mouse position, like you had, especially for a game or something like that, where you're hovering, or if you're using some, let's say, a graphics program where you might be drawing like a crosshairs at the mouse coordinates, and you want to know at all times where the mouse is, you would need to have that event enabled. That's just an example off the top of my head, but that kind of thing. And I'm sure, like, MUI applications and reaction applications that have pop-up help, like little info boxes, they would use that event to read where the mouse is and see if it collides with a gadget box. So there, absolutely reasons to have it. But I'm taking it out for what I think is a good reason, and as well as that for a slow Amiga, just saves you a few, throwing away CPU cycles. So what I'm doing is, this one has a lot of checkboxes. The last time when I was doing the GadTools tutorial before, I can't find the OS define for this, and I think it's because it's done a little bit differently in Blitz for whatever reason. But you have to set the flag $200, and you have to set it in when you define the gadget. So it's hex 200, and that lets you set a proportional gadget. So normally a checkbox is in 2:1 proportion, as in on a standard PAL screen, where you've got pixels that are 2 times higher than they are wide, it looks like a square, or it looks close enough to a square. But but if you're running it on a square pixel resolution, like this is kind of probably going to be run mostly on, because it's going to run on a very low res screen if it's run on the game screen, it looks like a squished little box. So using $200 means you can actually define the X and Y proportions, and it's 16 by 16, which makes it square. So you need to define that when you create the gadget, or it doesn't work. Now, MUI and support for reaction. There is not direct support for reaction in Blitz Basic, unfortunately. Yeah. Yes. Yeah, I think there's something wrong with the OS define, and it doesn't. It's either wrong in the resident file, or it's or there's something else going on within Blitz. But yes, fair play, you came to that same conclusion. But yeah, so there isn't any reaction support, unfortunately, or class act for that matter, which is the predecessor to reaction. It would be nice, And in theory you can use it, but you have to use it in the same way you would use it in C. So you don't have the nice you don't have the nice sort of predefined stuff in there that you would use Blitz for. You might as well do it in C. So you can open the library manually, and you can use you can convert if you have the FD file. If you have the, yeah, it is a nice system, to be fair, and it looks, especially if you're using if you're using on OS4 and everything else, it looks a lot nicer, and it adds some extra gadgets that are pretty cool. But you need to there's a file descriptor file, which is a .fd file, and that describes how a library is laid out. You need to get that. You need to import that into a program that comes with the Blitz environment, and that will give you sort of a wrapper, a bare bones wrapper for the library, and then you can use it the same way you use OS calls, like give me an OS call. So it gives you a token that'll look like this, with an underscore at the bottom, which denotes that you're directly accessing an OS library. So you can do that, absolutely. And then, but yeah, everything has to be done the same way it is in C, which is like, defining pointers, defining your structs, your tag lists, all that kind of stuff has to be done manually, which is fine. You can do that. It's just, you lose the convenience of using Blitz, basically. So I don't know. It's not something I've ever kind of delved into, and I probably should, because I would like to use reaction as well, and it would probably be possible to make an include file with loads of wrapper functions that do it and give it a sort of a Blitz type interface, because Amiga Blitz comes with a lot of them for a lot of the OS libraries, but not here, unfortunately. But anyways, yeah, so there's our checkboxes. These are our slider gadgets. We covered them before as well. Now, slider gadgets in the Amiga, in Amiga OS, run from between two arbitrary values you give it, but they're integers. Okay, so this for sensitivity runs from 5 to 99, because I initially had them running from 0 to 100, but a 0 sensitivity, literally makes zero sense. Because if you set it to 0, all your inputs are multiplied by 0, so it gets, you can't do anything with it. Yeah, I don't need that, George. I don't need. I have enough projects, for the love of Jesus. Yeah, I'll put it on the list. It has been on in the back of my mind for years to do that, but yeah. What I also need is to port all the Ami Blitz includes back to Blitz 2, so that they can be used in Blitz 2 programs, because I've done it for a couple of them because I wanted them for a particular project, and it's not that hard to do, but there are certain things that need to be worked around, and some of the workarounds are awful. It's just, it's very mind-numbing. Like, Ami Blitz, for example, supports variable number of arguments to a function, whereas Blitz 2 doesn't. Actually, you know what? It's less needed now. But Blitz, back in the day, a few years ago, Blitz 2 didn't need an FPU, for example, whereas Ami Blitz does, or did. Now that has been fixed now, but there are a couple of reasons, because some commands behave slightly differently, and the compiler. I can't even remember what project it was now, but the compiler made a balls of things in Ami Blitz. I think it misaligned something, and it meant that it only ran on an 020, and it would crash on a 68,000, whereas the exact same code compiled on Blitz 2 would work. And it was just one of these things, and I think it's been fixed now, but it harks back to that day. So maybe I actually don't need that. Maybe I can bump up the reaction library. But anyways, there you go. But some people do still use Blitz 2 when they're on very limited machines, because Ami Blitz is a little bit slow if you're, and it won't run on let's say a stock 1200, you need about 6 or 8 megs of fast RAM to run Amiga Blitz, whereas Blitz 2 runs in 2 megs. So you know, so that's a reason. It's not a reason I would ever use, because I'm not that kind of masochist, but you know, there are people out there who still run things like this from floppy disk. I don't understand these people, but horses for courses. Anyways, so this is kind of the same thing, and this is what I was saying about the mouse flags earlier. So we're checking these 2 bits to see if they're set, and then all we do is we set the attribute, the checkbox checked, to 1 for checkboxes where that bit is set. So X is inverted or Y is inverted. We just set them based on what the current settings are. You can define a flag that enables or disables the gadget on startup, but it's not as simple as adding on. You would have to like calculate out the flag to an integer and then add it to the flag field. So it's simpler to just, or more intuitive, I suppose, to do it this way. And it makes practically no difference speed wise, you know. And then we've got our event loop, and I don't really need to go through that. It's very simple. Oh, you know, look, I am actually doing bit set and bit clear here. I was talking about bit test earlier, but bit test, bit set, bit clear, these are bitwise operations that translate directly to assembly, and they are basically assembly commands. I don't know why I did it this way instead of using masks, like anding and oring things together. Yeah, it was just 2 different days. This is just, you know, today I feel like doing bitwise operations, today I don't. I don't know. I don't know why the difference there, but there you go. Maybe one of them I was drinking, the other one I wasn't. Who knows? But yeah, one was a weekend, one was a weekday. I don't know what the story is there, but yeah. So bit set, bit clear. These work in an interesting way because you do an A operation B instead of like a basic function where you do the function and then bracket A comma B. You do A operation B, and then you get your result. So it's kind of an exception to the rule where everything with brackets is a function and everything without it is a statement. And so there are a few exceptions like that, and they're almost invariably assembly commands or assembly tokens, or very similar. So other ones would be XOR and things. Oh no, I actually think XOR. Yeah, see, XOR, it works like a traditional function. Brackets, expression. But yeah, you just have to pay attention to the documentation. I'm not even getting documentation, so I'm pressing help here, and it's not even firing for that. It doesn't recognize it as a keyword at all. Some assembly stuff is a bit funky in Blitz, but if you're dealing with assembly, it's generally assumed you know what you're doing, and you don't really need the help stuff as much. But yeah, anyways, so what bit set and bit clear, what they do is, so they take the variable that you give it, or the value that you give it. No, it has to be a variable that you give it, and it will set bit 0 or clear bit 0. So that's bit 0 was the least significant bit, and setting it means setting it to 1, and clearing it means setting it to 0. Just to confuse things. So bit set, bit clear, and then this does the same thing for bit 1, which is the second bit. Yeah, but anyways, there you go. And then we just get the. This is done slightly differently as well, in that we don't act on the cycle gadgets. We're just taking the we're just recording all the values when the accept button is clicked. Okay, and then if we're not accepting the values, we just do that. But mouse sensitivity is saved in. Now remember, this is a float, but it's an Amiga style float. We've got sensitivity 0 and 1 for the X and Y axes. And that's the slider level divided by 50. Okay, so if we look at our slider level, our slider goes from 0 to 99. Well, it goes to 0. I had said 0 to 100, but 0 to 99. So basically divided by 50 means it went from 0 to 2, or to 1.95, 1 point, whatever it is. And okay, and so that's our sensitivity value, and it's an actual float value. But what I've done is I have said the thing actually goes from 5 to 99 because, yeah, a sensitivity of 0 made no sense. And if you turn sensitivity right down, you can't use the control at all, and that's just silly. So the sensitivity at 5 is 0.1, which is quite low, and it's very slow, but it's kind of a reasonable extreme low limit to give it. So this is how we translate the values, and you can see here the default value. We take the sensitivity when we're defining the gadget and we multiply by 50 to get our integer for the thing. Now obviously this is never going to translate 100% perfectly, but for something like sensitivity you don't need 100% perfect floats. If you really wanted that, you could set the slider to go from 0 to 10,000 or whatever you wanted, whatever resolution you need, but we don't need that. So but basically that's it. So all we do is we read the attribute, which is the slider level for the slider gadgets, which are 3 and 4, divided by 50 gives us our float. Blitz the compiler does quite a decent job of deciding what variable is what type, and if it's doing a calculation and it finds that one side of it's a float, it will return a value from the calculation in float format. It does a reasonably good job of doing that, whereas there are some other languages where you'll get an integer result for that calculation, or you'll have to cast it, so you'd have to cast these to floats before you do the calculation, or it'll just shoot you in the foot. It'll give you 0, 1 or 2. So Blitz does a good job of deciding what's right in these situations. Okay, I've taken some shortcuts here, but I know that event code 45 is a raw key event code 45 is escape, because I've just typed it and I've looked it up so many times. So I haven't gone using lookup tables or anything like that for it. I've just typed it in, hard coded it. So that closes the window if you press the escape key. That's fine. And we do the same thing. We free up our resources, flush the events, and go back to window 0. Controller options is basically the same thing. I'm not going to go through that like that again. There's one thing I will go through is just the way I put some labels in the window. I'm going to show you the window, what it looks like. So you can see here we've got some interesting labels. So we've got invert x-axis, left and right, invert y-axis, left and right. Now, how this is actually done internally is this checkbox here, the label for that is invert x-axis left, and the label for this one is right. Okay, so this isn't separate text, that's all one label for this checkbox. It's fine, it's simple. These guys are a bit different because you only get one label per gadget. These sliders have the gadget sensitivity above there and dead zone above it, and these sliders have none, and that leaves the X and Y labels to do. So I was trying to print them directly using various text routines into the window, and it never really worked properly because of Blitz. It's just a bit of a mess. So what I did was I defined a text gadget, not a string gadget, a text gadget here in this size, and put the X and Y values in it. Just literally, when I say the Y values, like strings containing X and Y, and that way they're always in the middle because they're defined between the two. The width of these sliders is defined by the width of the window, so they're calculated away from the sides -5, and therefore this middle portion is always the same width, and we can define the gadget to take whatever space is left, and then we just put the X and Y in there. And the reason, like I said before, the reason for that is because I couldn't get the text to print properly. And I tried a few different things. I tried printing the X and Y. I tried printing the dead zone labels and stuff like that. It never really worked properly either it would work once, but when you reopen the window, it wouldn't render, or it just didn't work because the font wouldn't. It tried to load Topaz, and basically it's just a bit of a mess. So so I ignored it and did it this way. Now, the $8000 flag means that the borders aren't rendered. And I comment there. Flag makes borders invisible. So I don't actually have a label on these, but the actual content is X and Y. And that's it. And they're just defined as right in the middle. So inner width divided by 2 minus 4. And that's it. Simple as that. Because there are no borders, well, because the borders are rendered invisible, it actually means there's 0 thickness, and so the font and everything is moved a little bit, a few pixels over, because there's no border. And so that's it. So inner width divided by 2 minus 4, because the font is 8 pixels wide per character, it's Topaz. Getting it right in the middle of the inner width minus 4 gives it right in the middle. Okay, and this is the same thing. We're setting the controller flags, except that instead of the mouse being just 2 bits and checking the first 2 bits and setting the first 2 checkboxes, we've got 5 bits involved. So there's enabled, and then X and Y invert for left, X and Y invert for right. And so they're all there. They're just separate bits. And then we do the same thing when we accept it. We do the same thing, but I've taken even worse shortcuts here. It seems we just cycle through the 5 check mark gadgets with a loop. Yeah, it should. Yeah, it's a little bit funky to do this. It's a bit of a shortcut, but I know the IDs are 0 to 4, so I've made a loop that goes through them all and sets bit I 0 to 4 to represent whatever's in the whatever's in the gadget. So if it's set or if it's cleared, we set or clear the relevant bit. Quite a shortcut way, but hey, fuck it. Yeah, it's probably late at night. If it works indeed. Exactly. But then what'll happen is I'll add another gadget at some point in the future, or someone will, and the gadget will show up fine, but the whole thing will go haywire because the results will be read into the wrong fields. So yeah, that's it. But it works so long as you don't change the defined values for those gadgets. Yeah, and yeah, I'm guilty of these shortcuts quite a bit. I wasn't making this for showing off, really. And again, the sensitivity sliders are divided by 50 to give a result between 0 and 2. Now, the dead zone sliders are 0 to 100. It's just the way it worked. It's still 100 pixels wide. Let's look at the the 100 positions wide. See, they go from 0 to 99. Hey, Proton Fig, welcome in, welcome along. How are you? Hope you're having a lovely Saturday evening. We're doing some programming here. I'm going through. This is a program I've been working on. It's basically an editor for the key mappings of the recent what's it called, Dark Forces port to the Amiga. So all the key bindings are stored in a binary file. So I've written a Blitz program that can deal with them and let you remap them. So that's what I'm doing here. I'm just going through the code and doing some funky stuff that I haven't covered in other Blitz tutorial streams. So that's what I'm doing. Just to point out, I did not do the main Dark Forces port. That is an excellent bit of work by Basili, if I'm pronouncing that right. Basili or something like that. A guy on EAB. And it's a great port. It's a very, very good port. But it doesn't have a way of configuring the key bindings, and the key bindings are stored in a file that looks like this. which means it's not easily editable by hand. But yeah. Oh, what have you been working on? Oh, excellent. Cool. Oh, were you streaming that actually? Sorry, I know Proton Fig is a streamer as well, and does some code streaming, and I'm assuming that's what you were working on recently. Oh, good stuff. Good stuff. Is this for the? Oh no! Did you enter this into the game jam? There's the Amiga game jam that's just finished recently. I don't know if you is this to do with that, or is this just a separate thing? There we go. There you go. Oh, it's C64 game. Ah, cool. Excellent stuff. I will have to check that out, and ever go and check out Proton Fig. He does some pretty serious coding. Well, anytime I've dipped into his streams, it's very impressive stuff. Yeah. That's it. My poor toddler-addled brain doesn't do assembly anymore. Not that it ever really did, but yeah, I used to be able to just about get my head around it, and now it's just too much. But I do sometimes check it out, and I kind of go in while I'm working on my own stuff. I'll have someone else coding and assembly in another window. But yeah, so yeah, I'll have to check that out. Absolutely. But yeah, so I was saying these sliders, they go from 0 to 99, so they have a resolution of basically 100 positions, and that's your dead zone setting, and it's 0 to 100, which translates into the floats 0 to 1. Okay, and they're stored in there as floats 0 to 1. Now, I haven't actually done this because I don't have a PSX controller adapter for my Amiga, so I'm just gonna leave that as it is, because that's kind of what's defined in the software. But there's a possibility that setting the dead zone to 1 means you can't use the game. You can't use your controller, or the maximum. But like, hey, that's it's not the end of the world. You just turn it down a bit. But yeah, essentially the value goes from 0 to 1 in the game itself. That's it. So you can set it from 0 to 1 on the Amiga side, that goes from 0 to 99, and you just divide it by 100 to get your value. So that's it. That's that routine. So that's pretty similar to the that's pretty similar to the mouse controls input. So now we get onto the save file and load file. Now I'm going to show you these, probably starting with the load file routine first. You will notice that save file is a statement, load file isn't. It's just a label, and it's because there isn't a function to load the file. I just do it in line in the main body of code. Probably naughty, but when it started out, it was only load file. That was it. It was just, can I even read this file? But what will make this interesting is I've used the Blitz, the Amiga Blitz include, the file include. So I'm not using the Blitz functions. I'm using the Amiga Blitz file includes, and they are quite nice. They're very nice wrappers for the OS functions, and that means that it uses nice some nice you can take advantage of any basically fixes or updates to DOS.library or any of the file system stuff that's updated since Blitz was released, so it can handle bigger files and things like that. So basically that's what it's about. Yeah, so what we're doing here is it's not done with objects, but a file ID, and the difference that means is file ID can actually be 0. So normally when you open a file with Blitz, you say it returns true or false. So if you open a file and it's true, you go. So you can do if open file, then do your stuff. you know the file's open. But because file ID will return -1 if it's failed, and it will return not a pointer, but a value of 0 or more based on how many file locks are open and stuff like that, if it succeeds. So you just have to be careful with that. It's the opposite way around. -1 normally means true, and 0 normally means false, but anything greater than or equal to 0 is true, basically, for the file handling stuff. So yeah, it's just, you know, it still catches me out every so often because I do it, and I just say, if file open, then do the stuff. But we've got our file ID. We need to store that in a long word because it can be any number, and we need to keep that because we'll use it later on. We're opening it in read mode, and that's our file. It's a relative file path. We're just opening it, so we're assuming that it's in the same folder, the same directory as our executable, which is our editor executable. Okay, and now the first thing is we read the header, and the header is just a kind of a magic number, and that's TFE with a null terminator. So TFE for the Force engine, which is the name of the engine that was ported, and you can see it here up at the top of our file. That's it there, and it's a magic number, and you can see it here in the ASCII representation. TFE and null. That is how it knows it's the right file. So we check that, and if it's that file, if it has that, then it means there's a pretty good chance it's a TFE config file. And if it's not that, then we say, well, first off, we've got our first nest here to say it's not a remap, unable to open the file, and then we give an error message if the header isn't right, that it's not a config file. And then we read in the version number. We're ignoring this. We can act on the version number because as the engine evolves, there have been some features added to the config file, and it's important to know what version you're running on. I'm not dealing with them because I'm not. So I just record the version, and when we're saving the file, we save back the same version number. It's just simplest. It is the latest version, and it's unlikely that the Amiga version is going to be massively updated. And even if it is, it's easy enough to change this to suit. But we're not going to use the Amiga version on an earlier version of the engine, which is kind of the main reason for this, because there are some flags that have been added since you know, the first version of this engine. So the Amiga has the latest version as it stands. Unless some new features are added in the future, the version number isn't going to matter. Anyways, we store it for later, and we save it out when we save the file, and then we import. I already talked about the bind count and bind capacity, and you remember before that the stem of this variable, we're missing the stem of this variable. That's because I've used the use path, and that's just the config stem variable. We're not using that here, you can see. So actions, and we have to give the full stem because we're not using use path, so we define the full length of it. That's fine. But here is part of why we do it in line. It's a bit lazy, but we set up our array of actions of action type, and we set it to bind capacity. So we're defining this array to be of size bind capacity. Or we're redefining it. I think we defined it up the top, didn't we? We did. Max actions. Bind capacity turns out to be the same number, basically. So you'll have to excuse that. It's unnecessary. Where were we? We were at load file. Okay. But anyways, we talked about actions. These are the actions that the game has. So they're all in there. What we'll do is we start reading. We've got our bind count, and we start reading our lines from the file. When I say line, I mean 4 words at a time. So we've got a word here. That's our action code. We've got our action type. We've got our key map code, our bind code, and our bind qualifier. So we've got 4 long words in each line. Line is an entry as far as this file is concerned for key binding. Okay. So So we start counting them. So our bind count, which we've just read, that's basically how big that section of the file is, and that's defined in the file. So header, version, bind count, bind capacity are these words here. Header is these 4 bytes. Version, so it's version 2, 2.2 I suppose. You can see there 002002. And then bind count is 46 in hex and capacity is 70 in hex. And yeah, that's it. What's 70 in hex? Is it 112? Is that going to work out for me beautifully? Oh, it is. It is. My trusty calculator. Oh, you can't really see that. But yeah, 70 in hex is 112. Former me might have known that off the top of my head. But yeah, anyways, so it works out the same size anyway. But bind capacity, the maximum number of binds, which is 2 binds per action. So you don't always end up with all of those defined, but that's the maximum anyway. So we've defined that. So we are basically reading through all of our binds, the bind count. We get our action code, and then we get our bind number. Well, we don't get our bind number, but there's no point in reading an action code if we don't have a free slot to put it in. So each action only has 2 slots. We can't store more than that. So what we do is we say our bind number is -1, but if our first code isn't there, then we say our bind is the first code. It's the first bind. We'll use the first bind. If the first, or else we'll check the second bind. If the second bind is populated or isn't populated, then we'll use that one. But only if the first one isn't populated. Okay, so now we've got a bind number of -1, 0, or 1. So if it's -1, that means there's no slot available for the bind that we're reading. And therefore it'll just, we can't store it anywhere. We don't want to store it anywhere. It's nonsense. The original game doesn't have that in the interface, so it doesn't really make a lot of sense either. Or it's not the original game, the PC version of the engine doesn't have that. So actions. So now what we do is, so we're saying it's not equal to -1. So now we just store it in the relevant slot. So populated, first off, we'll set populated to be 1. So bind number is 0 or 1. And then action type, we'll say is a read long. So a read long just does what it says in the tin. From file ID, that's the file ID we got when we opened our file. And we read that long value and we store it in that slot. Same with that one, the map code and map qualifier, they're just read longs. That's fine. Bit of debug output there for if we need it, but that's disabled by the compiler if we set the debug constant to 0. Now, if the bind number is actually -1, which means that we've no slot for it, we still have to read the 3 values, because if we don't, our file pointer will be completely out of sync, because we still want to read the rest of the values correctly. So this is only ever going to run if it's a malformed file, but still there's a possibility that in the future some file format will allow 3 slots per bind, for example, and someone will copy across a config file from the PC and it will not work and it'll just go nuts because you didn't read these 3 words. So this is just a safety factor here. Still need to read these inputs to keep everything aligned, and you can see I clearly copy and pasted that line. So yeah, so we just read 3 more longs. So just to visualize that, so if let's say, we've got bind hex 16 here. If this is the 3rd time we've hit bind hex 16, if we just moved on to if we just ignored them completely and moved on to the next bind, it would say the next bind is 0, and it was try to assign 52, 0 and 17 to bind 0, and obviously that's not right. So what we do is, if action 16 is full, both slots are full, we just go ignore, ignore, ignore. And then we move on to slot 17, or action 17, which maybe has slots available. So that's why we do that. It's just a safety feature. It's just it's forward planning, I suppose. Like I said, it would be a pretty corrupt file, or like there's something funny's happened if that actually needs to be used, but it will make it at least partially compatible with a funny file from some other version of the program. Okay, now controller flags we read in, that's fine, and then we read each of the axes defines, and we read them in, that's fine. Now we read in our sensitivities. So this is a nested function. We read a float value. Now here's the thing, when we read a float, the file read float function from the Amiga Blitz file include literally just sets up a float value and pokes the 4 bytes and reads 4 bytes and pokes them in a particular order. And therefore, if you save in Amiga format, in Motorola format, it will be a Motorola float. If you save in Intel format, it'll be in Intel format float. So it doesn't actually process it in any way, shape or form. So initially I thought, oh cool, I can just feed that straight into the math library and translate it. As I was saying earlier, that bit works fine. But when you try to do it the other way, Blitz mangles the results, so you can't do it the other way around. So, but that's fine. So we can just read that directly as a float. We pass it through the IEEE to fast floating point function that we made earlier, and that's our Motorola format floating point number for sensitivity and dead zone for the controller. And then we've got the mouse flags, and we do the same for the mouse sensitivity. That's it. Some more debug output and there are error messages, and that's it. And now we are almost at the point of opening our window. So basically this is where we get to opening our window. What I'll do is I'll show you the equivalent in the save file function. So we've shared the variables like that we need: header, version, input config, and actions, because that's basically it. And our error flag we've set to false. So now we do file force write. Now the reason I say force write there isn't because it absolutely will write it in any conditions, but if you don't do force write, if you just do file write, if the file already exists, it opens it without overwriting it. So if you start writing to that file, you overwrite the contents, and that means that if you write a smaller file, or if you write fewer lines or fewer entries into the file will still have the original. I can't concentrate when you're doing that. Yes, use the force right. Basically, if you just open it in write mode, you don't blank the file, so you can end up with like straggling bytes at the end of the file if you make the file shorter than it was. So there you go. That's what I'm trying to say. Tasty. Okay, so but that's why force write will obliterate the existing file. And same thing, if you get a file ID, you have to check that it is greater than or equal to 0. So same thing, we write. What we're doing is we're just writing the exact header that we got from when we opened it, the exact version we got. And now, because the bind count, we don't keep track of it in the main part of the program when you create new binds or you turn them on and off. I've just had to do a bit of a dirty counter here to count them, because you need to write the number of them before you've actually cycled through them. So you have to count them first and then save them to the file and then write them. Now I could seek back in the file and write it. It's probably how it should be done, to be honest, for efficiency, but it's simpler to write the file in one straight linear go and just sacrifice the CPU cycles on the right when you choose to save the file. So that's what we're doing. We're basically, if it's populated, we will increase the bind count, and if the second slot is populated, we increase the bind count again. That's fine. And now we don't use that number except to write the bind count, because what we do is we cycle through every action all the way and write it if it's populated. So I've got two loops, and because old school programming and loops, we do the inside loop as J and the outside loop as I. So J is our actual action number and I is our slot. So the action numbers go from 0 to 55 or whatever the max actions is. And for each one of these, we write I was actually storing the action code, but that makes no sense in this format. But if it's populated, we write first off the action slot, the action code, which is like 0 to 55. Then we write the type, the map code, and the qualifier all as longs. Then we after we've gone through all those 55, then we go and do it all again for slot 1, which is the second bind for each one, and that will write it in pretty much the same order that it's stored by default. So yeah, there you go. We could have done it the other way around and write, slot 0, slot 1, slot 0, slot 1, slot 0, slot 1, but that's not how the game itself writes the file, so I thought better to replicate that. Now we write the controller flags. Again, that's fairly standard, and the access flags or the access definitions. Now, here we go. We get a dummy variable, which is a long word variable, and we store the floating point result of the conversion back to IEEE format, back to Intel format for the sensitivity values. And like I said, storing it as a long makes no sense if we're ever going to do that. If we're ever going to do, if we're ever going to deal with it, but we're storing it as a long so that Blitz doesn't absolutely crap all over our floating point format. Because it'll say, oh, I see you're trying to save a floating point number. Let me arrange that for you, and completely fucks it up. So we convert it, we save it as a long, and then Blitz just trusts me that I've got the bits in the right order and saves them as they are. So we write a long to the file. Same size, 32 bits, but now the bits are where I want them to be because I've put them there. Oh, you can see there's my old code for the right float. That did not work at all. Did not work at all. Oh yeah, I have a comment there. We're writing longs here so they don't get mangled by Blitz's float handling. The polite way of putting it. Write the flags, and then we do the same for the mouse sensitivity. And that's it. If we can't open the file, we give an error message, and that's basically it. Simple enough. So we've done that. That's our loading and saving, and now here's our interface itself. First thing we do, build up the list of actions. Now the list of actions isn't really used for anything, as in, well, it's never modified. So all we do is, it's pretty similar to how we built up the cycle gadgets with all the different names. We just go through the array of action names, and that's it. I don't know why I have two versions of this here. Two different ways of doing it, but basically I had a different approach before, so we don't need that code there. So if we can add an item to that, we just have to check that, because if that fails, it's a dynamically allocated list. So if that add item ever failed, we have to check that before we try and store something in it, because if we don't check that and it does fail for whatever reason, a memory fragmentation issue or something like that, we will shit all over someone else's memory with this line. So we have to check that whenever you add something to a dynamic list, you have to check that it's okay. And once it is, then you can save your information to it. So we've added the name to the item name field, and then that's basically what shows up in our list gadget. do some calculations to figure out what window size we want. But window size we want is fixed because we want to open it potentially on the game screen, which could be 320 by 200. So the maximum size we can use is 320 by 200. We add some IDCMPs here. Now, slider IDCMP and list view IDCMP, you see both of those have been added to the default events list, and you need to do that so that the list view gadget actually works like it should. Because if you don't do that, the list view gadget fails to receive the events from the host window because you've kind of blocked them. And again, I've taken out the mouse move gadget or the mouse move event for debugging and CPU saving reasons. Flags are kind of the same as the other ones. New look menus, I've set that flag because this window has menus attached, and new look menus gives you the color codings that OS 3 and above use. If you don't do that, you get sort of white on black instead of black and white, I think. Or you get the old Amiga key symbol and stuff like that. So it's just a thing that you set for all the new windows. And new look prop on is another one of those. That turns on the it makes the prop gadgets look a bit more modern, a bit more like you expect them to look. Okay, and this is setting up our list view. We covered the list view in another tutorial, so here's the array that we filled earlier, list view items. And that just sets it up. That's fine. All our gadgets are all set up. It's kind of done that. We've got our menus. And we disable some gadgets first because none of the items are selected. None of the items are selected in the list view. So we start off with nothing highlighted, and therefore the gadgets, it isn't relevant. It doesn't make sense to have the gadgets active. So that's it. Then we've got menus are set up. There's not many. They're just different ways of doing everything. The only thing there that you can't get from clicking buttons is the about requester. And that's just a message to say, I made this. Okay, so, and we set selected variable represents the currently selected item, the currently highlighted item in the list. And so we just, set that to -1 because nothing's selected at the start. And basically, this is fairly standard stuff. Key thing is, we run the new selection subroutine if the user clicks on an entry that isn't already selected. So if they've changed their selection, we go to new selection, which is down here. First thing we do is we check if the previous selection was -1, which means nothing was selected. Then we enable all the gadgets that let us do things. And now we change selected to the event code. And now we check so we change the action type. So basically we make sure that if it's not in use, that we set it to -1, which represents what's it called? None. Represents disabled. And so the same for the second one. So we set the string to the key names. That's basically and we got it again down here. This gets the key name from the code that's stored. So it's a key name, the SDL key code, not the Amiga key code. And for that map code, and basically just the current setting of it. And we put that in the box. So if it's a controller, it'll return button X, red button, D-pad up or whatever. And if it's key code, it'll return that. Or if it's a mouse button, it'll return left mouse button. And we set it to that, and that's it. So we used to have the qualifier out in this window, but we got rid of that, so we don't need that code anymore. We also set our cycle gadget to the action type +1, because if our action type is -1, that's none. But in terms of the cycle gadget, none is 0. So everything's offset by 1. So we have to make sure we do a +1 there, so that we get the right thing. And it's the same for we just repeat it again and some debug output there. So then that is reversed if we look at the type here, so we store the action type is the event code -1 because everything in the gadget is offset by 1. So we take away 1 and we get our action type. So it just means that we could insert none as the top of the list. And it also corresponds to if anything sort of falls through and we get a 0 result somewhere, that ends up being -1. And yeah, that's it. So yeah, so basically if we click on the get, we launch the function that why is that not a debug output? So that would have output regardless of whether we were debugging or not. Yeah, but that's fine. So we launch this function, the get code function that opens the big window that has all the options for setting a key code and the qualifier and stuff like that, or a mouse code or a controller button or whatever. That's all in there, and the code we get back is what we store. If it's not 999, if it's 999, it basically means we got a nonsense code back, and then we don't do anything with it. We just ignore it. I don't like the look of this. This is slightly awkward feeling to me. Why is that not nested? Where's that second if? Oh, I see. That's better. Okay, and get to is basically the same thing. If actions selected. Oh. Yeah, we didn't add that for the second thing. That's a potential bug there. Actually. Yeah, I think that might be, yeah, it might have been a previous bug. There was a weird bug that under certain circumstances, certain codes aren't saved, and I think that could have been it. Although no, that shouldn't be. That's just the other reason that I added that to try and combat that bug I was saying earlier, where the window would open even when it shouldn't have. Yeah. Can't get staff these days. But yeah, no, that was also, I added that to try and stop that bug from happening, and it was still happening. So I thought I'd fixed it by adding that code there. So it shouldn't have opened the window if the action type was -1. But obviously that didn't work because I didn't put the same code in for get2. But I'm also going to add code to disable get2 when I excuse me, when at some point I'm going to disable that so you can't even click the gadget. Now the last thing in here that's interesting, I suppose, is that I added some keyboard input. So the raw keys for the up arrow and down arrow are 76 and 77. There are hex things as well, but I just got this by printing out the event code when I pressed the buttons and to see what it was rather than look it up. It depends on whether the manual's already open or not. These things do, you know. So up arrow and down arrow, what we do with these is we actually adjust the selected entry in the list view. So what we do is we set let's say for the simplest one, the simpler one is the up arrow, so we're moving up the list. So if our currently selected item is greater than 0, because we don't want to go past the 0 entry or terrible things will happen, bad things, crash. So if it's above 0, we set it -1, and we subtract 1 from it, and we set the list view selected item to the current the new EC, the new currently selected item. Now, just because if you do that, it will scroll. That's fine. That will move the selected item up and down in the list view, but you can scroll out of what's visible. So it's very simple, and it's not particularly neat. But what we do is we get the current top item, which is the attribute GT list view top of our list gadget. We get that item. If it's greater than 0, we subtract 1 from that. So again, if we're above 0, we go back. And then we do the same thing for the down arrow, except instead of checking against 0, we check that we check that it's not disabled and it's less than max actions. So it's between 0 and the maximum number we can have on the list. And we can see what happens if we do that. So if we do that, and I can use the keyboard to go up and down, which is cool, and that works fine, except that it's it's a little bit more work. I would like to make it so that you move up to the middle of it, and then then it scrolls up. But you know beggars can't be choosers. I'm going to leave it as it is because unlike MUI, you can't tell how many lines there are. As far as I can see from the documentation for this gadget, you can't tell that there are 16 lines there. Therefore, I want to only move when I'm in position 8. So but it works. It works fine. It's intuitive, and if it will always move to, like, if I go like that, the highlighted one's way up out of the screen. But oh, there's a bug. It should have jumped back. But I guess because it was against the bottom. That's annoying. Well, what do you know? There's another bug. I guess it just updates the list in parallel to the current entry. So it works fine when it's visible. Okay. Yeah. Okay. That's another thing on the list. So I'll have to make the code a little bit more elaborate around here. Okay. Anyways, yeah. So what we do is we also fire off the same routine new selection that happens if we click on the gadget. And that's basically it. That is our program. That's how it works. And I've gone through all of that. I was thinking I would add some more stuff to it. Let's have a look at the bugs that I have open on this. Okay, the simple stuff we have. PS names instead of Xbox. Okay, so this is the first thing we need to change is the thing. But basically, that's how the program works. I've gone through all the code there. If there are any questions, let me know on that. But that's, I think I've covered everything that I haven't covered in other streams as well. But there's some stuff there that I've kind of skipped over, the GUI stuff that I've done in more detail in previous streams, and they're all on YouTube. Where's the YouTube? Oh, sure. There you go. Have a YouTube. So the previous streams have the more detailed stuff on making a GadTools interface relatively sensitive to border widths and font sizes and stuff like that. There are limits to this, and I'm making a compromise by using a fixed font and only allowing a certain amount of space. But if you look at this, oh, what the fuck has happened here? Oh, that is a bad pointer somewhere. Please insert program is running in any drive. I'm not going to do that. It's a bit special, and now I notice I'm missing an arrow from my gadget here. Something bad is happening in Amiga land. Oh, it still works. But now here's the thing. I had new look prop on, and I've just realized that this has actually changed. It's got a white thing, and before it was the black one, which is not the new look prop. Something funny is going on with that pointer. I've just realized with this gadget definition. Ah. Yeah, bad things. Now, I did that to see if also the slider gadgets in the sub windows were acting up. Now, here we go. Illegal instruction. And it's a guru. This is bad news. Bad news. There is nothing illegal about that instruction. It's a checkbox. Pretty simple stuff. Inner width is 252 pixels. There's nothing invalid there. The string buffer has got corrupted. That's what's happened. Because, see, Blitz has a sort of an area that it uses as a string buffer.
Oh dear.
Yeah. I'd say the string buffer, something bad has happened. This is bad news. Let's see what happens now. I bet you the whole thing caves. Yeah, there we go. Oh, let's
Oh dear.
let's up our crash count. Hey, we were doing well there. We were doing well. Anyway, we'll do it now. Reboot and some. Yeah, we did all right. We did all right. I probably should have called it. I probably should have just left it there. But okay. Let's go back and have a look at this. What was I talking about? What was I doing? We were doing that. Oh yeah, I was going to change the configuration, the defines. But yeah, so let's run it now and just see what it looks like, because yeah, look, it's the old style slider with the black in it. That's the OS2 style slider. And it's the same in there. And that's, see, I was kind of used to it. I kind of forgot that I'd set that flag. So there's something, that flag is doing something to some memory somewhere. That's badness. Yeah, I'm only after clocking it now. Thanks to a memory leak somewhere or something, some corruption of the string buffer, the Blitz Basic string buffer. I don't know, but I will have to check that out. That is for another day. Anyways, let's low hanging fruit here, guys. To use one of those corporate bingo words or phrases. Okay, so PSX names. So look, we've got access names. We've got, where are my controller names are up here, aren't they? Nope, they're down here. Controller names, here we go. So A is red. See, oh yeah, I kind of missed them all because they're all doing that. By the way, there's a data, there's a string sign in the back of that data statement. That means that the data is a string. Normally you just do data, and that means you're doing numbers. So, you know, but yeah, to do strings, you have to actually define it as a string data. I think you can do data.s as well if you want. You can also do data.w, data.b as well, you know, for to explicitly define it. But it's not really going to make any difference generally, except the amount of space it takes up in your executable. That's all. Okay, so button A, B, X, and Y, they are Xbox buttons. I'm going to redefine them. Oh, I have a list somewhere of A is cross. Of course, that's the most used button. So A is cross. Let me see. So B is circle. This is just making these strings longer, which is a shame, but it would be nice to have these symbols defined, wouldn't it? And Y is triangle. Triangle, and then back and guide. Guide. See, annoyingly, guide in this list that I have here is mapped to start. Whereas on the CD32, I would have said play maps to start. Indeed. Don't know what to do with this. Don't know what to do with this. Yeah. What I'm going to do with it is going to leave it as it is. And if someone wants to file a bug report, they can file it. Because we've only got one middle button, if you like, on the CD32 pad. So it has to map to either start or guide. Yeah, you see. So the guide is the Xbox button, which maps to the start on the PSX controller. Yeah, they are. So but this gives us a weird situation where we're missing a code. Because if we change this guide to yeah. See, that's what it would look like on the PlayStation. But then, what the hell does start map to? So, let's go with that. Hopefully no one actually maps anything to that button because it doesn't exist. Let's actually do it properly. Let's put that in there. Let's just do it that way, and then if anything falls through and it does happen to end up like there, we can do an unknown. I just hope that's how it's done, because if not, you're going to have to map the pause button to unknown on the CD32 pad. Let's see what happens if we run that actually. Pause is there. See, it's there as a define. Back guide, you see, and the PlayStation doesn't have back, does it? What I really need to do is mask them out, but then it's the PSX controller for the Amiga, so it's the PS1 DualShock analog, as far as I know. So PS2 basically, PS1, PS2, but they're the only buttons it has. So it has start and select. It's kind of or start and what is it? Start and system or something. I can't remember. It has two buttons in the middle, a square one and a triangle one. Select and start, yeah. Whereas the Xbox has three. Appreciate that. The Xbox has three, which means SDL has three, which means we can in theory map any of those three functions, but they don't exist. But if I exclude them from this, it means I have to have a lookup table for this gadget. I am just going to undefine them. Because what I can do is I can take them out of there, but then the codes won't match up for the D-pad for the buttons that are beyond them. So you have to subtract two for now, one from start play. So I'm going to leave it like that, and I'll let some people do some testing. I don't have one of those interfaces. I don't think you do, Graham. And I'm not going to buy one for this. So I'll let someone report it and I can just change it and adjust it. But if people moan about it having unknown entries, I'll do a lookup table that has the fewer entries, so it'll be fine. But there we go. I'm gonna tick that off for now. The next one was shorten texts. Oh yeah. Shorten texts, because in the list we've got night vision tog. It just looks a bit messy. So how do we shorten that? Because I could use a smaller font, but then we have to find a font that can be distributed, and the user has to install it. You know, it's messy. But a smaller font would be good, to be honest. But I think that one's probably fine. Everyone's going to understand that. Cycle previous we. Probably a bit better if I just go previous weapon. Let's have a look. Cycle previous we. No, wrong file. I was in the right place, wasn't I? So you see, the difference is in the actual tell you now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 17 characters. So there is a different function. Yeah, and absolutely, that was my first thing. But if you look, there's previous weapon, next weapon, and then previous weapon. And I think what this previous weapon does is it swaps weapon. So, you know, if your previous weapon was weapon 2 and you're on weapon 1, I think pressing previous weapon goes 2, 1, 2, 1, 2, 1. Whereas cycle previous weapon goes through everything you have. Last weapon. Very good. Not just a hat rack. Stop doing that. There's a function to compile a whole project where you've got multiple files involved. It was never finished in Amiga Blitz, and that's kind of like should be done. Okay, yeah, that looks good. Previous weapon, next weapon, last weapon. Decrease screen size. Minus screen size. Yep, that's a fair point. Menu, night vision. Yeah, because none of them are realistically going to be hold buttons. That's a good point. So system menu toggle. I don't know what the difference is there. System menu. System menu, game menu. I don't know what actually that function does. Let's maybe you're more familiar with this. What's it? Is it the use menu or something? Menu. It's system menu is F1 and menu is escape. I'm going to do menu for that. Then, yeah, night vision toggle. Night vision, cleats, gas mask. Oh. Headlamp. Oh, decrease and increase screen size. I'm going to do minus and plus. Headwave toggle. Hood toggle. Holster weapon. Auto mount. We don't need it. Toggle. Let's see. How does that look? That already, even without reading it, that looks nicer. Map enable scroll. It just about fits. Cool. Well, everything fits now, but that's a weird one. Map zoom in, zoom out, map enable scroll. Cheers. See what's the difference between the escape and F1 menus. Okay, so they all look fine now actually. That's cool. All good. In the meantime, there's another bug where if a function wasn't defined, so if function was defined as none, it didn't save, and the reason for that I see here is because when it gets switched on, when the option gets changed, it all works, the interface works, but it never gets the populated flag set. So what we're going to do is, so you can see here, this is the type 1 and type 2, so the two type drop downs, or it's two type, what are they called? Cycle gadgets. We're going to set the field with once they fire off. So, so our event code is EC. So if, well, what we can do is we know if EC, so if EC is a positive number, that means we've selected a valid mode. So then we should do populated 0 equals 1. And if it turns out that it's actually 0, we'll do that. And that should solve that bug. And we'll do the very same for the second type 1. We just change this to 1, 1, and that should do it. We should also GT enable and GadTools is 0, and what's the, it's get 1 as the gadget. Yeah. And we'll do the same here. Get 2, and then we do GT disable. Oh well. Undelete, and we go up here and do undelete there. So, so escape is the system menu, and F1 is so mission menu. Excellent. Thank you very much for that. Very good, very good. And in the meantime, I should have added some GT disable and GT enable functions. Oh. Where's that? Where is my cursor? No terminating quote. What's happened here? What the actual fuck is happening here? Terminating quote. GT list. That's weird. We haven't changed anything here. Yeah, but mission menu. Yeah, but it's got, it would give me the error in the include rather than in it's saying get 2. Now what the fuck is happening here? Also, whoa, also it's given a column number of 337. The widest you can go is 250. Where's that after coming from? Yeah, it's, to be fair, it's right. It said it's after the get to. But that's clearly memory corruption, or well, is it? Where could that have come from? Yeah, that, Jesus, that's a bit scary. Or did I manage to paste something or something stupid like that? Anyways, console, system menu, mission menu. Mission menu is escape and system menu. They're the wrong way around, aren't they? System menu is F1. Mission menu is escape. Yeah, they're the opposite way around. Mission menu. System menu. No, I know. And boom. Okay, also, if we click here, okay, we need to also do the, so keyboard, and we set that to none, disables the get. Yeah, okay, that's working. All we need to do now is do that in the, when you click that gadget. Okay. If actions was PDA, F1 there as well. Possibly, but that's just it is well spotted. That might just be me. Oh, it's, you know why? One of them's got a qualifier. Oh no. I have a feeling one of them had a qualifier and I may have just messed that up by changing the bindings around. I'm nearly sure one of them is Alt F1 and one of them is just F1. Or maybe my qualifier gadget isn't being set right. Yeah, I wonder. F1. Let's just say that has Alt as a qualifier. Yeah, no, that's working. It might be. I'm nearly sure one of them is supposed to have an Alt qualifier, because if you look at the actual binary file, it's in there. So Alt F1 for system menu. Yeah, okay. Rather than escape. Alt F1 for system menu. I don't know. But anyways, it can be rebound, escape, Alt F1. So what's the difference? So I would call that the system menu. The abort mission, F1 gives the mission menu. So we got 3 different menus then. Alt F1 for system menu. Okay. Okay. I don't know. I will. Yeah. I'll leave it as it is, because that's not really my. It's, you know, it's beyond the scope of this, I think. I'll have a play with it myself and see if there's, you know, see if maybe they do need to be reworked, but I think they should be fine. So the last thing I'm going to do, and then I'm going to go to bed, is I'm going to enable disable the gadget. So actions, GT enable, yeah, get one. If action selected, oh no, so that should be disable. Alt, yeah, well, Alt by itself is crouch, yeah, but there seem to be, you can use it as a qualifier, and I think it's defined in by default. Oh, Jesus. It seems to be defined by default as against one of the F buttons or something like that. I'll check it out again. But anyways, oh, that's wrong as well. Get, and then we want that. Else that, and then disable. Cool. That should be it. So when we click, why is that getting enabled? And that, no, it's backwards, isn't it? Get to, yeah. That all seems to be fine. Let's start it again and click on something that we know definitely doesn't have a second bind. Yeah, that's what we wanted. Cool. All working. Excellent. This is good. Oh yeah, and let's have a look at our controller. Triangle / yellow. Okay, cool. Do they all fit the new defines? They do, just about. Cool. Okay. Well, I am going to call that there. That's pretty cool, I think. It's all working. Thank you very much for your help, Graham. And thank you everyone for coming along. That is whew. I think that was some good work, but I think this will probably be added to the main Dark Forces archive as a kind of as in when you go to the controller settings in Dark Forces, it will open this program and let you do your configuration, and that should be it, I hope. Yeah, no, I didn't actually want to do that. Turn off that, and then we'll do that. That's fine. What I'm going to do is let's see if there's anyone online to raid. Is there anyone online? Who's available? Cheers, George. Thanks very much for dropping in. Thank you everyone for dropping in. That is cool. Where is my stuff gone? Let me see. There's no that girl Joey, what's she doing? Martian Gothic PS1. I think we can give that a go. Let's see. Yeah, sure. Let's give that a go. Sure, a bit of for anyone who's still up and wanting a bit of jump scares or whatever. I'm not actually sure what Martian Gothic's about. I've never played it. Never even heard of it. But it's PlayStation 1, and we were just talking about PlayStation 1. So there's a vague link. Oh, hey, Cammy. I didn't realize you were there. Hey, welcome in, and good morning. And good evening. And yeah, thanks very much, guys. That is excellent stuff. Where is my... yeah, let's go and raid that girl, Joey. Oh, hold on a second. It's saying Scottish Serenity's on. I'm going to raid Scottish Serenity if he's on. Let me see. He is. He is playing Gris. What's Gris? Oh. Indie looking game. Let's go, Scottish Serenity, a member of the Scottish Amiga user group. He is not playing Amiga stuff, but we'll go and rate him. Okay, right, let's go. Well, I appreciate you being here anyway, Cammy. I appreciate the lurking, but no, I really do, and thank you very much for taking time out of your morning. And yeah, thanks for coming along. And yeah, it will be on YouTube and stuff like that at some point. But yeah, cheers, guys. I will talk to you all soon, and have a lovely rest of the weekend. I'm going to go to my bed now and sleep and sleep and sleep. Right. Bye-bye. Good night. Cheers, guys. Bye.
Hey, Dallas. How you doing? I don't know if I'm going to the right place. How you doing? I didn't realize you were streaming tonight.
Hello there.
Hey, Amiga Kami, how you doing? Where am I going? I think I might have went the wrong way.
Hello there.
How you getting on? Are you programming tonight? Or have you been programming tonight? Oh crap. Have I just screwed up? I might have screwed up. I think I might have screwed up here. Ah, nice one.